This is opening ceremony for Broadnets 2020. Thanks for your attention. In this year, Broadnets 2020 got 32 papers submission and we accepted 14 full papers from that. Thanks for your conference committee, such as Professor Shan Shenpeng, China University of Petroleum, China. Professor Rui Li, Xidan University, China. Professor Yu Shenshu, Xidan University, China. Professor Sheng Weizeng, Shandong Normal University, China. Dr. Ramon J. Duran Barroso, University of Valladolid, Spain. Dr. Ignacio de Miguel, University of Valladolid, Spain. Professor Hongao Gol, Shanghai University, China. Thanks all of you, although COVID-19 impact and we hold online. Please pay attention to next year conference. The scope of this conference target one of the key drivers for 5G, the IoT world that includes technology advances in cyber-physical systems and security. The conference is also interested in novel work applying 5G concepts to space and underwater communications. The conference aims to provide a platform where to disseminate and discuss key innovations and technology trends in this fast-evolving arena. We also expect that the future conference will be as successful and stimulating.
Dear ladies and gentlemen, let me welcome you to the EAI Broadnets 2020, the 11th EAI International Conference on Broadband Communications, Network and Systems. My name is Kristina Petrovichova and I'm the Conference Manager of Broadnets 2020. Unfortunately, due to the COVID-19 emergency, I'm not able to meet you all in person. Therefore, I'm using this opportunity to address the organizing committee, the keynote speakers, the authors and the participants on behalf of the European Alliance for Innovation. Thank you for being a part of this conference. In particular, I would like to thank the General Chair Professor Zhenchen Pang and the Steering Committee member Professor Hongao Gao, together with the whole organizing committee for their hard and excellent work throughout the whole process of conference preparation. During today's event, there are truly many ways how you can actively participate and enjoy the online interaction. During the streaming, there is a Slack platform available for all the participants where you can discuss the presentations and participate in Q&A sessions. Upon accessing the link below for Broadnets 2020 workspace, you can enter all channels. I would also like to use this opportunity to invite you to join us for the next edition of Broadnets 2021. We will keep you updated and the news about this event will be available on the conference website. Should you be interested in becoming a part of the next year edition organizing committee or the technical program committee, please do not hesitate to contact us at the email address below. In addition, if you are interested in organizing an event with EAI, such as a conference, a workshop or a seminar, please do not hesitate to contact us at the email address as well. We will be happy to provide you with more information. Now, our community manager, Michal, will talk more about what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention. Enjoy this conference.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
I'm Robert Chodorek. I would like to introduce paper possibility of using existing wireless LAN infrastructure as an emergency network for air-to-ground transmission, the case of WebRTC-based flying IoT system. First will be a short introduction. Next, I talk about air station and ground station, WebRTC technology, test environment, present some results and conclusions. Currently, in the main monitoring system, we is using IoT system with base it's unmanned area vehicle. Flying monitoring system consists of one or more air station and corresponding ground station. The ground station and air station are connected using some kind of wireless technology, wireless local area network. Air station consists of two main elements: IoT carrier, it's unmanned aerial vehicle, and the flying IoT system. The flying IoT system consists of a single board computer. This single board computer is, in our example, is Raspberry Pi. On this Raspberry Pi run WebRTC application, it's an IoT broker, and to this single board computer it's connected 4K video camera and set of environmental sensor. Also it's connected global navigation system. It's in our system we use module with can use GPS, GLONASS and Beidou navigation system. This is a photo of our air station. It's on our testing environment. It's IoT carrier, it's quadcopter. Use it in our example. This quadcopter it's using a Pixel flight controller. It's easy to expand. It's open source software of this controller, and it's connected 4K video camera with a gimbal, which allows to set proper direction of camera and stabilizing this camera, and set of sensor. This is a gas sensor used in our environmental monitoring. It's one of sensor used, and on the top we can see first it's a Raspberry Pi. It's part of green part of this board, and on the top it's visible global navigation system. It's composite of several navigation systems, receiver, and in results accuracy of this position of this air station. It's measured at half meter or better. We don't additional reference base station. Ground station, it's composed of two elements, WebRTC multimedia and monitoring station and command and control console. This WebRTC multimedia and monitoring station, it's a WebRTC-based IoT broker which run on computer device. As a computer device we can use desktop computer, but in our experiments with laptop, because it's more portable, we use a special laptop with and also we can run on a smartphone which can run WebRTC capable web browser. The command and control console we're using for piloting OAV. It's a separate devices working on the same than wireless LAN bandwidth, 2.4 gigahertz, but it's a different technology. It's a digital radio control. We use it digital protocol for transmitting some command and control. We use 4-channel command and control console. It's enough for piloting typical unmanned aerial vehicle. For some control of IoT system, we're using a separate channel inside WebRTC technology. This is a slide of general architecture of the flying IoT system. It's an air station connected to several access points. This access point is connected to the switch. This switch is connecting this access point. Also, we have some infrastructure for registration or wireless devices like air station card of single board computer. Also in this infrastructure we have a monitoring station, wireless multimedia and monitoring station. Command and control console is connected directly to air station. As air station we use quadcopter with this Raspberry Pi, and this is a connection to external internet and set of server necessary for storing and for running application, both for air station and ground station. The WebRTC technology is used for transmission data from air station to ground station. It's on the application level. Also, this WebRTC technology is used to build our application. Typical WebRTC application is a single page application. It's necessary to using this technology of building application because it's necessary to preserve state of processes. And this WebRTC technology it's working inside typical web browser. Currently used web browser including main browser currently used by many users. It's support WebRTC technology. WebRTC technology inside it's three part. It's for audio, video processing and for transporting data. In audio part we can find codec for audio, coding and compression, and also some mechanisms for improving quality of audio. The same it's video. It's used a typical codec in older version VP 8, currently VP9. It's available in current implementation of web browser, and also we have some mechanisms for enhance and improving quality of video. In part of transport we can find some part with communication between two web browsers. This include a special set of server and mechanism to connect web browser behind network address translator and firewall. On this communication function on the top we have multiplexing services, and for real-time communication we use secure version of real-time protocol. And all function is available using WebRTC application program interface. Inside web browser is written in C++, but it's available in our application as a JavaScript function. For transmitting media stream, we're using RTCP pair connection and secure RTP transport protocol, and for telemetric stream from many sensor we use data channel with STTP protocol with encryption. All data are encrypted. Data for media stream and for data channel it's transmitted as encrypted, therefore it's safe when we analyze a typical monitoring system. And also in this stack we can see additional mechanism for WebSocket communication, which allows to establish communication between web browser and a necessary element of WebRTC communication we call a signaling server. Streaming media from camera and non-media data from sensor are aggregated in this technology and sent to the ground station. And the ground station is receiver, demultiplexed and presented on the ground station and resent to internet to next analysis. And we analyze complex infrastructure, production network. This production network uses a set of access points. In analyzed system we have 3 access points available in our network infrastructure. We have some assumptions to build this network. The production network may or may not be dedicated. We can use dedicated network or partially dedicated or currently used network. Main motivation for our contribution is to answer this question. We can use it's possible to use in emergency situation existed infrastructure in urban area. Not it's necessary to build its own infrastructure or not. In emergency situation we can find several part of existed infrastructure in the urban area. Typical additional communication not using wireless network, wireless LAN technology, use it for example LTE technology or some other cellular based technology. It's in emergency situations sometimes it's overloaded. Another reason why we not use in this case this network, it's stronger asymmetry of transmission, because we can sometimes download very high speed but upload it's lower, sometimes under required quality of this monitoring system. Our monitoring system uses 4K video camera. It's not enough for some transmission. Experiment we carried out in our parking lots of our university. Experiment it's provided in two typical scenario. One, it's a temporary special built for this environment network, and another it's using existing permanent network infrastructure in scenario 2. This is our parking lot, our air station, 3 access points connected, and air station connected directly to command and control console. WebRTC multimedia monitoring multimedia station, it's connected via wireless LAN environment. And we analyze several transmission, and in the paper it's two characteristic, two interesting part in this transmission on this line and on the larger point on our parking lots. And this permanent infrastructure is close to our access point, but some different location. And when we compare some selected results, for results it's in the paper. First, we compare relative signal strength measured in scenario 1 and scenario 2. It's this longer trajectory. And when we analyze in dedicated network, we have seen better signal strength. It's from when we start in close access point, signal strength it's lowering, and when we go to the another access point, it's higher. And in not dedicated network, you have a lower quality, but enough to provide proper transmission. And when we analyze available rate measured and air station, we can find that possible data rate from air station to access point, it's for dedicated network it's higher, but it's when we analyze non-dedicated network, it's stable, starting from enough for our transmission, and lower part it's enough to provide proper 4K transmission and data from all sensors. And we go to conclusion. Experiments show that dedicated network gives a little bit better performance, but it's a cost of building this infrastructure and time necessary to set up this network, and this usage of existing infrastructure, which is designed to work in this given area, not for air-to-ground transmission, gives a satisfactory result. Thank you for your attention.
Hello, my name is Michał Morawski, and I'd like to present the results of our research concerning tuning and improving MPTCP protocol stack. Although we are focused on industrial application in our research, the results of this research can be applied in general networking as well. What is multipath TCP? Multipath TCP is the recent version of TCP. It's designed in 2012, 2013, and its improvement is focused on usage multiple paths of communication simultaneously. This protocol consists from 4 modules: path manager, which establishes and tears down paths, as well in initial process, establishing connection process, as well as during movement, the terminal movement, and so on. If user want to send some data, the master controller acquire this data from the buffer, the user buffer, and it shape the general stream using some general properties. Usually it is a fairness. Then scheduler takes the data and split over currently available paths. The data is transferred to the peer using ordinary single path TCP used and known from years. How is advantages and disadvantages of usage MPTCP? Of course, higher throughput. Of course, resilience of network failure and congestion, and seamless mobility. We can shift from Wi-Fi to LTE and another Wi-Fi and so on. However, it is not free of charge. MPTCP versus single path TCP consumes more memory, more CPU cycles, it increases latency, and this is main goal of our research, increase energy dissipation. The energy dissipation depends not only on interfaces itself, but as well but it depends on the main processor activity. In industrial application, most of these applications use on-off traffic pattern. The device sleeps, and after some time elapsed in response of the external event, it performs some action. Is it worth to think about power consumption? Yes. On the left side of the slide, you will see typical properties of common interfaces, Wi-Fi, LTE, and Ethernet, and we can see that, for example, Wi-Fi, legacy Wi-Fi takes legacy Wi-Fi interface takes more energy during transmission than IC modern, but less energy for keeping energized this interface. But it is not a crucial point. Crucial point is movement. If we move from one side to another side, the coverage changes, the RSSI changes, and the right side of the slide you will see how this is measurement, how the RSSI changes during walking from one side, from one point to another point. We'll see here we can achieve throughput 250 megabits per second, and here maybe 20, maybe less megabits per second. Sometimes one interface is better, sometimes other interface is better, and application should follow these changes. During tuning, we have additional requirements. First of all, simplicity. The MPTCP protocol is complex. So, what is complex? It should not be more complex. So, any changes required low CPU and low RAM, low memory overhead. The changes should be resilient from different traffic patterns. Some applications are restricted by networks, and other by application logic. We have short stream and long streams. We have different technologies, link layer technologies, and the solution should work in all of them. And third, the requirements is any changes should not decrease advantages of the standard MPTCP protocol. And what done? Path manager. Default setting is established as many paths as possible in the initial state. But it's not idea, but not a good idea when we have short streams. Short streams, why? For example, very often industrial application exchange data using GET or POST requests, HTTP requests. There are very short communication. Some other, the communication is longer, but the short communication is common. At the initial state, the protocol stack does not know which kind of stream will be transmitted. Application as well. Therefore, we propose to wait a little. If we can establish application, use only one path. It's usually better path, primary. Then, if CPU and the congestion window is exhausted, then another path will be established. Such solution is fitted from short requests like GET and POST. However, it decreases efficiency of protocol if we have a little longer streams, a little longer. Because if we have a long stream, this impact of this the proposition is negligible. Path master controller. Default setting will to preserve fairness. However, if you consider the industrial application, the fairness is usually not a problem, because the bottleneck is on first mile on link after first mile access. If the common links are usually fiber, very fast communication, there is no bottleneck on this. Therefore, we postulate to drop the fairness consideration in design of MPTCP master controller. However, such solution cannot be used in common networking because it requires fairness. Scheduler. Scheduler is part of MPTCP protocol stack, which splits data over the paths. In general, the default solution split direct a given segment using a channel with lower SRTT, smooth round trip time. There are many other schedulers proposed. However, we propose a scheduler that use the channel with lower W, it is power efficiency, times in flight divided by SRTT channel. If this solution is formally proved, is mathematically adjusted, it is not heuristic, the proof is one can find in the paper. This solution allows to skip usage channels with higher power demands. And from the transmission point of view, it uses smooth, transmission is smoother. And the implementation is very simple. You know, it is only 2 operations more than default scheduler. It's one multiplication and 1 division. We have not observed any disadvantages of this scheduler. And final, S-BVT controllers. In default stack use TCP Reno. In fact, TCP LIA, but LIA is multiple version of Reno. However, Reno is obsolete version of TCP. We have currently more smarter and less aggressive TCP like Cubic and BBR. In particular, BBR is well fitted for green networking because when nothing unusual in network, there are no drops. Applying modern TCP, we have low drops and higher throughput than using default settings. However, the changes requires recompilation of kernel because it's not in place in modules. This is a disadvantage because in every version of Linux, the MPTC protocols are changes, and we can find appropriate point to change the sources. How we can check if it works? We use simple setup which consists from Raspberry Pi as an agent and two public networks sending data to server, to concentrator to the server. The public networks is one is consists from 8 hops, other from 16 hops. This is a real network. Therefore, because we have using real networks, we do not use sophisticated MPTCP master controllers, but because we need to preserve fairness. And use 2 scenarios. Scenario 1 is destined for the checking path manager in the users and small streams, short streams. And scenario 2, longer streams is used, and power efficiency is set according 3 ABC from 3 split ratios from 3 ratios. And what results we obtained? You know, we optimize energy dissipation. However, this slide shows network properties. This is a side effect. SRTT drops 4 times, maximal SRTT 4 times, and changes very slowly, very smooth transmission. In flight data, the blue line shows imbalance. It's mean how shows if the scheduler makes mistakes in splitting data. It should be 0 all the time. However, it is of course impossible, but should we keep as low as possible. On the left side, we'll see tuned settings, and the right side we'll see default settings. The difference is very high. The maximum imbalance is about 300 segments, and in tune settings, and about 1,400 in case of default settings. In details, this is only part of our research. The full details you can find in the paper. You can see increase throughput, decreases drop count, and energy gain. In some special cases, not always, the energy dissipation is halved when used tuned settings. Conclusions. Why MPTCP stack offers number of opportunities to improve it. It is not mature protocol yet. If we use heuristics, common in networking, then difficult to obtain significant results. Of course, it is possible, but it's difficult to obtain. However, if you use formal mathematical methodology, we can prove the solution presented here is good, is correct. The changes we can introduce in the code is very simple. In terms of informatics, in code changes, complexity, and so on. However, the network stack is improved in energy gain. It's objective of our research. In terms of drop count, it's always objective. But in terms of throughput, it is not objective. But it is a beneficial side effect. Thank you for your attention. I wait for your questions.
Hello to all of you. My name is Hemant Rathor and I am here to present the paper Identification of Significant Permissions for Efficient Android Malware Detection. The other co-authors of this paper are Professor Sanjay Kumar Sahay, Ritvik Rajvanshi and Mohit Sevak. So we'll start with a brief detail about outline. So we'll start with a bit of introduction. Then we are going to talk about research questions followed by framework design and different performance matrices used in the paper. After that, we are going to discuss in detail about experimental setup which we have designed, followed by a discussion on different malware and benign data set, followed by the process of feature extraction, feature engineering, and different feature reduction methods used in this paper. Later on, we are going to talk about different malware detection models we have built using traditional classifiers, ensemble classifiers, and deep learning methods. Later on, we are going to talk about results and discussions. Finally, we are going to conclude the paper. So let's start the presentation. So as we can see here on the graph, on the left-hand side graph, has been an exponential increase in the number of smartphones sold in the last decade. In 2009, there were around 172 million smartphones sold, and this number is expected to reach 1,710 by 2021. Smartphones are used to store a lot of personal information like messages, pictures, contacts, which might be targeted of malware designers. So we have to be careful about malicious attack on smartphones. Also, smartphone uses operating systems for resource management. So here we can see that there is a duopoly of Android and iOS in smartphone operating system market, with Android having 85% of the market share and iOS having 15%, around 15% of the market share. As I have already discussed, that smartphones are used to store a lot of personal information, and that might be targeted by malware designers. So let's talk about a bit about malware. So what is a malware? Malware comes from the term malicious software. Android malicious applications are designed with a bad intent to steal personal information or spy on users, etc., etc. Initially, malwares were developed to show one's technical knowledge or skill, but now it is a profit-driven industry. Different individuals, organizations, states are designing dedicated malware attacks on a particular system or organization to reap benefits out of it. So also there has been exponential growth on number of Android malwares. So in 2012, there are around 2 lakh new malwares detected on Android, and this figure is expected to reach 35 lakhs in 2017. So let's talk a bit about literature survey in this domain. So there are two types of malware: static malware and dynamic malware. In static malware, the code which performs malicious activity remains fixed, doesn't change. In dynamic malware, the code which performs malicious activity change itself so that it can evade the detection process. So once we know that there are different types of malware, now we need to build different detection engines to detect these malwares. So there are multiple detection engines present today. The first one is signature based, then we have heuristic based, and then we can use machine learning and deep learning techniques to detect malicious software. If we are using machine learning and deep learning, we can use different features like permission, string, API calls, etc., etc. Android permissions are the backbone which provides security to the Android system. The whole Android system security is built around permission systems. So we have used Android permissions here to build a malware detection system. So let's talk about research questions which we are going to answer in this research paper. So the first research question is, do malware designers use specific Android permissions to perform malicious activity? The second research question is, can a reduced Android permission set be constructed for efficient Android malware detection? So by default, we have around 200 Android permissions, and if we try to build malware detection system with all 200 permissions, we might suffer from curse of dimensionality, which we are going to discuss in this paper. So can we reduce the number of features with different feature reduction, with the help of different feature reduction techniques to build Android malware detection? That is the second question. The third question is, do Android malware detection models based on machine learning tends to use less computational resources as compared to deep learning algorithms? So this is the third question which we are going to answer in this paper. So let's start. So this is the proposed framework which we have used to build different malware detection systems to study them in detail. So the first step here is data collection. Then we are going to talk about feature extraction, then feature engineering, and in the end, we are going to talk about different classification algorithms or models. So in data collection step, we downloaded driven dataset for malicious applications, and for benign applications, we have used Google Play Store. So we downloaded around 8K applications from Google Play Store and used the services of virustotal.com to actually check each application is malicious or not. If an application is malicious, it is removed from the dataset, benign dataset. So once we have created malicious and benign dataset, then we have to perform feature extraction step to build the feature vector. So we have extracted Android permissions and build the feature vector. To understand the feature vector better, we have performed the process of normalization, and we have also performed correlation analysis on the feature vector. After that, we have performed different feature reduction steps or methods like attribute subselection and attribute creation to reduce the number of features. We have used variance threshold, PCA, and autoencoder to reduce the number of features. Once we have received different we have used different feature reduction methods, then we have used different type of classification algorithm to finally build the detection method. So we have used classifiers like decision tree, KNN, SVM from traditional set. From ensemble set, we have used random forest and ADA boost. And from DNN, we have designed 3 models, DNN 2L, 4L, and 7L. In the end, we are going to compare all these classification models on different performance matrices. So what are the different performance matrices we have used? Right, so classification algorithm can be evaluated based on 4 performance matrices: true positive, false negative, and false true negative. And we can derive other performance matrices out of this, like accuracy, recall, TNR, and ROC out of it. So we are going to use all of them for comparison of different detection models. So let's talk in detail about the experimental setup. So as I've already told that we have downloaded malicious dataset from driven dataset, and for benign dataset, we have used services of Google Play Store. Right. Then we perform feature extraction, and the later step was feature engineering. So in the first step, we have normalized the frequency of permissions in malicious and benign applications. So the bottom graph shows the normalized frequency of permissions in malicious and benign applications. So here we can see access network state, internet, and write external storage is heavily used by benign applications, but sometimes used by malicious applications. On the other hand, send SMS, receive SMS, read SMS, and etc. are heavily used by malicious applications and are rarely used by benign applications. So this is a wonderful insight when we normalize the feature vector and studied it. We also performed correlation analysis of permission used in malicious applications. So out of this, we got a wonderful insight that read SMS is used in tandem with write SMS to perform malicious activity. Send SMS is used in tandem with receive SMS. Right, both of them are largely dark. So we can say that send SMS is used largely with receive SMS or in tandem with receive SMS to perform malicious activity. So these are the few insights when we perform correlation analysis. Then we perform we use different feature reduction methods to reduce the number of features. The first feature reduction method which we used was variance threshold. So in this, we first calculate the variance of each feature and then plotted the graph which can be seen on the left hand side between variance and number of features. We can see here that around 100 permissions are having 0 variance or close to 0 variance. Around 80 permissions or 90 permissions are having variance, a higher variance, right? On the right hand side table, we have sorted permissions based on the variance. The first permission, which is read phone state, is having highest variance and is ranked 1. Write external storage is having second highest variance and it's 92, and the list goes on. Here we can see that there is a bend around 16 permissions, right? So that is why we have set a threshold of 16 in various threshold to extract permissions, top permissions which are having highest variance. So the threshold set here was 16. In the same way, we also perform PCA, principal component analysis, and try to reduce the number of features. The graph shown here is between the accuracy and the number of principal components drawn, right? So initially when the number of principal components were low, then the accuracy of the classification model is also low. But as we go on increasing the number of principal components, the accuracy is started to increase, and it stabilizes around 16 principal components. So we have reduced, or we have set a threshold of 16 principal components for feature reduction step here. We also perform feature reduction with the help of autoencoder, right? So we have built two types of autoencoder with 1 layer, autoencoder with 3 layer, and then try to reduce the number of features. The below graph shows the training and validation loss and AOC for different epochs for autoencoder 1 layer. As we can see here that initially in the initial epochs, the loss is higher and it stabilizes as we train further as we train further. Same goes on the right hand side graph, where in the initial epochs the AOC is pretty low and it stabilizes around 80 epochs. So we have trained the autoencoders till 80 epochs. So this is the summary of feature reduction step, right? So in the original data we had 197 permissions, right? With various thresholds we were able to reduce number of permission to 16, right? With PCA autoencoder 1L, we are able to again reduce the number of permissions to 16, and with 16 and 64 respectively, and with autoencoder 3L, we are able to restrict to 16 permissions. Right. A point to note here is PCA and autoencoders are feature creation method, right? So they have merged multiple features, right? So we do not know the exact permission which is used. On the other hand, with various threshold, we have the list of permissions which are already shown in table 1. Now, with the help of the feature reduction step, right now we are able to reduce the number of features, and now we are going to build different classification models. So we have built 8 different classification models using different algorithms derived from traditional classifiers like decision tree, k-nearest neighbor, and support vector machine. With ensemble classifiers, we have used random forest and AdaBoost, and in deep neural networks, we have designed 3 neural networks, one with 2L, one with 4 layers, and another one is 7 layers. The bottom graph shows the training and validation loss process. So this table summarizes the performance of different classification models with respect to different feature reduction step, right? So here, if we talk about the different performance of different classification model with respect to accuracy, we have to look at column number 3. So the highest accuracy is received by random forest with original data, which is around 94%. The second highest accuracy is again achieved by random forest, but on VT, variance threshold data, which is around 93.3%. So there is a drop of 0.7% in accuracy, but we are able to reduce the number of permissions from 197 to 16, which is around 92%, reduction. If we are using AUC as the performance metric, the highest AUC is received again for our random forest with 98.1%. So here we can say it is able to balance the TPR and TNR pretty nicely. In terms of training and testing time, if we are comparing, we can see that the deep learning models are almost able to achieve around 92 to 93% of accuracy, but their training and testing time is very high as compared to other classification model. The least amount of training and testing time is achieved for KNN and DT, and the random forest is also performing pretty nicely with respect to accuracy it has achieved. But DLN models are taking a lot of time, lot of training and testing time. We have also compared our classification model with 10 different most popular antivirus, and we saw that we have achieved highest amount of accuracy here. Right. So to conclude this paper, what we have found wonderful insights in this paper. Right? The first thing is the highest accuracy is received by random forest with 94%. If we try to reduce the number of features here, we are able to attain almost similar accuracy, which is 93.3% with VT and other classification model, which is around 92% reduction or 8% of the original set. And the fourth conclusion here is the deep learning models achieve comparable accuracy against machine learning models, but they have a massive amount of training and testing connected. With that, thank you for listening. Have a nice day. Take care. Bye bye.
Hello everyone, my name is Liang Guangjun. I'm come from Department of Computer, Information and Network Security, Jiangsu Police Institute, Nanjing, China. It's my honor to introduce my article, Energy Efficiency Optimization for RF Energy Harvesting Relay System. My partner is Xi Jianfang. She's come from Electronic Engineering School, Anhui Polytechnic University, Wuhu, China. The others of my partners is Wang Qun, Xia Lingling, Li Meng. They all come from Department of Computer Information and Network Security, Jiangsu Police Institute, Nanjing, China, and Jiangsu Provincial Public Security Department, K Laboratory of Digital Forensics, Nanjing, China. You know, there is a hot research point is energy harvesting, and RF energy harvesting. Now, let's introduce my abstract. This paper conducts research on the RF energy harvesting relay network and propose an improved energy harvesting relay protocol, which allows the energy harvesting source node to retransmit data to improve the system diversity gain and constructs the energy harvesting slot allocation, subcarrier pairing, and power optimized mode of the distributed system energy efficiency. Resource allocation algorithm based on optimum energy efficiency is further proposed. The Dink batch method is used to transform the non-linear programming problem into a line programming problem. Then, the Higlum algorithm and the subgradient method are used to obtain the iterative algorithm based on energy efficiency optimization. Simulation shows that the algorithm we proposed reduced the complexity of the outcome, and it has a good global conversion. This research has been supported by National Natural Science Foundation of China, and the high-level introduction of talent scientific research startup founder of Jiangsu Police Institute and the other foundations. In the section of the introduction, we introduce the radio frequency energy harvesting technology, and examined the wireless networks. It is a hotter research part. Many reference applied RF energy harvesting technologies to the cumulative radio network synthesis earlier. They considering the PPP model and use them in the wireless sensor networks and D2D communication scenario. In our article, we consider an RF energy harvesting multi-relay scenario, which includes a base station, a source node, and relay nodes. We proposed HTC relay protocol. In this protocol, the base station broadcasts energy to the source node and the relay node on the downlink channel, and receives signals from the source nodes and the relay nodes on its upstream channel. After the source node connects radio frequency energy from the base station, it is collected energy transmission data. Taking the maximum energy efficiency of the system as the optimization goal, the transmission power of the entire network is restricted as a constrained condition. Also, then, the energy efficiency optimum mode of the joint subcarrier pairing, power allocation, and time slot system assessment is concluded. The proposed optimization model is a mixed integer non-linear program. We use the dispatcher method and Cauchy inequality and Hagram algorithm method to solve the problem. The main contribution of this paper are summarized as follows. Firstly, in our article, improved HTC relay protocol is proposed to allow the source node to retransmit the unsuccessful signal in the last time slot on another subcarrier. Such themes can significantly improve the energy efficiency performance on the system. Secondly, we propose the optimization mode, which is a mixed intelligent non-linear programming problem. The method of deriving the equivalent channel gain simplifies the objective function and reduces the computing complexity of the objective function. Thirdly, for an iterative process of energy efficiency optimization, a joint resource allocation algorithm is proposed. A joint allocation is based on the principle of the energy efficiency optimization, power allocation, sub-carrier pairing, and time slot segment. The system model and program description has shown in Figure 1. From the picture, we can see there is a base station, a source, and multiple relay. Section 2.2 is the description of the proved HTC relay protocol. See from the Figure 2. The whole transmission has two stages. Stage 1 is the energy transmission. Base station transfer energy to source and relays. In the second stage, there is data transmission. Source first trans data to base station and relays, and after received the data from the source, relays relay the state to base station. In our improved HTC protocol, the source use the energy come from energy harvesting to retransmission the data in the second, or we say in the second or third data transmission stage. Sector 2.3 is the problem description. Problem 1 is the energy efficiency problem. The sector 3 is energy efficiency optimization algorithm. We adopt iterative algorithm to save the energy efficiency problem. You can see in this table. Now we can the final section, simulation and analysis result. From figure 3, we can see the red line is the poster EE the double E scheme. We can see we proposed the double E algorithm has better energy efficiency performance. Now we can see the same inclusion in the figure 4. Now there is a conclusion of paper of article. We emulate the IF energy harvesting relay network scenario, and we proposed improved HTC relay protocol. After we save the energy efficiency problem by Dinkelbatch method and Kersey inequality and algorithm, we can see in the section of simulation we have better system performance. Now my presentation now this is my this is my presentation This is my presentation. Thank you, everyone. Thank you.
Good morning, good afternoon, and good evening. My name is Li Hao Chen, and today I will present our paper, Analysis of Queue Schemes and Shaping Strategies for Large-Scale IP Networks Based on Network Calculus. Okay, first, abstract. Our paper will be talking about IP network and the quality of service. We will focus on the latency guaranteeing, which is one of the key aspects of the queues, and we will use network calculus as a theoretical tool to analyze the end-to-end delay upper bound. And we noticed that there has not been any studies that relating IP networks with network calculus because IP networks is extremely large and is very complex. So in this paper, we will summarize 3 queue schemes and analyze their efficiencies based on network calculus. Also, the effect of ingress shaping will be investigated. In the end, we will give an IP network use case and analyze that use case based on network calculus. The IP network has a history. There are many attempts at trying to provide better quality of service. So there was ATM, InSurf, and nowadays the DeepSurf dominates the IP networks. Beyond DeepSurf, actually, the devices, the schedulers, are just doing priority scheduling and round-robin scheduling, very basic scheduling schemes. And on the other hand, network calculus first getting used in avionic networks. And then we have audio and video bridging network using credit-based shaping to provide delay guaranteeing. And then there is time-sensitive networking. And also in IP networks, we have new applications and demands on quality of service always exist. So in this paper, again, we will focus on the delay upper bound. We summarize 3 major paths towards better quality of service: non-time-based queues, time-based queues, and logical separated network. InSurf, DeepSurf, and credit-based shaping, also asynchronous traffic shapings, they belong to non-time-based queues. In the Perfinet IRT, TT Ethernet, as well as time-aware shaping and cyclic queuing and forwarding in TSN, they belong to time-based queues. Also with new techniques like Flex Ethernet, it enables the third one, logical separated networks. There is also DetNet deterministic network, which is a IETF working group. It uses TSN's data plane technologies. Its goal is also to provide deterministic delay. So the basic feature of non-time-based quality of service is actually schedulers, that we have algorithms that help the scheduler to make decisions whether and which packets in which queue can be selected to be forwarded. And time-based queues is that we implement a gate, and the gate will be open or closed based on the time. Logical separate networks is that we have, for example, only one physical port and one physical link. However, using some techniques, we can separate one physical port into several logical ports, and the data can be outputted through different logical parts without interfering each other. So we think the feasibilities of non-time-based queues and LSN is moderate because of some reasons, and time-based queues is a little bit hard to implement in IP network. However, In this paper, we want to analyze something that can be analyzed in a quantitative way. And that one would be efficiency. And what is the meaning of efficiency? We will discuss it later. So before that, let's look at the analytical tools we have. First is simulation, which is commonly used, but it's time or resource consuming, especially for large cases, and it is hard to get the actual worst case. On the other hand, we have theoretical analysis. In this paper, we use network calculus. So the basic of network calculus is that we need to modeling the traffic as a level curve and modeling the capability of devices as service curve. So you see in this figure, the blue line is the level curve, which is the upper bound of the traffic that can arrive at a device. The burst will be no more than this B, and the long-range average rate will be no more than the R. And we have the service curve, the right line, which lower bounded the service capability of the device, which means a packet has to wait at most time t, then it will be served at a rate R. And we can easily get the delay bound, which is the maximum horizontal deviation between these two lines. And this is the delay bound of one hop. And of course, there are algorithms in network calculus that can calculate the end-to-end delay bound. So for now, we will not go into details about those algorithms. Okay, finally, we've got to the meat of this paper, the most important part. So we have this queues model. We have one flow as the flow of interest, which will be analyzed. Then we have many flows that we name them as queues needed flows. And of course, the flow of interest is one of the queues needed flows. Besides, we will have other best effort flows which don't have any requirement on the delay. So this alpha is the arrival curve, and the alpha H, the alpha L are the aggregated arrival curves. So it describes the aggregated behavior of those flows. So here we have the forwarding device, which might be a router, might be a switch, and here is the scheduler. And inside the scheduler, we can implement different kinds of queue scheme. The overall service capability is the bandwidth, and the bandwidth is R. Here are some important hypotheses that we believe in IP networks, the total amount of flows is huge. So we think the R, the average rate of the flow of interest, will be much less than the RH, which is the aggregated rate of all other queues needed flows. And this also holds for B and the LL. Now the analysis begins. We have a FIFO as the baseline that all the flows are going into the device into a FIFO queue, and they will be served one by one. And we have strict priority that all queues needed flows have a higher priority than the best effort flows. The scheduler only have to serve the burst of the queues needed flows. We also have a strict priority combined with deficit round robin. So here we can set the BI and the QI, which means how we separated all the queues needed flows into different high priority DRR queues. And by setting the quantum of the DRR, we can give a more flexible scheduling. And here in this formula, we suppose that we evenly divide all the queues needed flows into DRR queues, and the quantum is also evenly configured. If doing so, then these two values will be the same in condition that we ignore the TDRR. And it can be ignored. The reason is discussed in the paper. And fourth is the logical separate network. And this one is easy because now we are serving all the queues needed flows with RH, which is the exclusive bandwidth for all queues needed flows. And fifth, we have cyclic queuing and forwarding defined in HOP 802.1. This scheme belongs to the time-based queues. For the time reason, we are not going into details. The result is shown here. And also, this can be combined with strict priority, and the result will be better. With some numbers given, we can get this result. And you could see that the non-time-based queues method has the lowest worst-case delay. You may remember we talked about efficiency, and we think that providing the minimum worst-case delay to a fixed amount of flows by a fixed amount of resource equals to using the minimum resource to guarantee a fixed worst-case delay requirement of a fixed amount of flows. And that, we believe, means efficient. And of course, there are other trade-offs besides efficiency. For example, the time-based queues can provide lower jitter. And if the money is not an issue for the user, then he can buy more bandwidth, then LSN might be a good option too. Okay, now we are going to talk about ingress shaping. So when we think of end-to-end delay, one easy way to add up the per hop delay, then we got the end-to-end delay. If we shape the traffic at the very beginning, make its burst less, of course we have a cost, and that cost would be the delay caused by shaping. Next, we would discuss what's the effect of ingress shaping. So here we have some definitions. N is the shaping multiple, and fair ingress shaping means the burst of all queues needed flows are reduced by N. So here is the result, the end-to-end delay using strict priority and shaping. The delay of strict priority would be multiplied by N because the burst is shaped, and multiplied by the number of hops, then this is the end-to-end delay. And of course, we have to add up the cost of shaping. And if you use this value to divide the original end-to-end delay value, then we would have the worst-case delay improvement multiple. This figure shows a lot of information. It means that the WCDIM is affected by many factors. For example, the P, which is the inverse of the burst share of FOI. The Q is the inverse of bandwidth share of FOI. The share means the bandwidth of the flow of interest divides the whole bandwidth. Here we could see that this 101 is the break-even point, which means at this point, shaping has no influence on the worst-case end-to-end delay for the flow of interest. Because here the inverse of bandwidth share is fixed and the shaping multiple is fixed, when the P gets larger, then the flow of interest will benefit from the fair ingress shaping. And P gets larger means the inverse of burst share of FOI gets larger means the burst share of FOI gets smaller. The smaller the burst of the flow of interest, the more benefit it will get from fair ingress shaping. And we could also notice that there are 4 lines with different helps. And this indicates that the more helps there are, the easier a flow that can be benefit from the fair ingress shaping. For example, compare these 2 break-even points. If there are 10 hops end-to-end, then though the Q is 100, the P only needs to be 10. And when the P is larger than 10, that flow of interest will be benefit from fair ingress shaping. By doing the similar things, we can have these two values for the cyclic queue and forwarding plus strict priority plus shaping. And also we have the result of the end-to-end delay upper bound of LSN plus shaping. We could see that here the first one have the lowest value because there is a 2 here and there is a M here. M means that the dedicated bandwidth serving the queues needed flows has to be smaller than the whole bandwidth. Otherwise, the best effort flows will starve to death. And we believe the result, if you only consider the efficiency using the same shaping strategy, that is a fair comparison, then we would say the non-time-based queue scheme is better than the other two. And on the 5th chapter, we gave a use case and also the analysis of the use case. We have an IP network model here. There is access ring, aggregated ring. The user flow will be going into the network through the 5G base stations and all the way up to the UPF and then all the way down. We simulate 3 different applications. One is electric. The other 2 is VR interact applications and VR video applications. Describe these applications like this, and we also know the latency requirement of these applications is different. Then we have some result based on different queue schemes. So you could see that by doing different strict priorities, we can have different and better result than FIFO. Also, LSN gives result. Maybe we cannot say it's better or worse, but it's definitely a difference. So we can design the network based on requirements. And all these 5 methods, we could use a specific algorithms in network calculus called PMOO, pay multiplexing only once. So this will result in a much better, much tighter theoretical upper bound. On the other hand, the CQF, because the mechanisms behind, we cannot use the traditional network calculus way to analyze the delay bound. Okay, here is the conclusion and future work. The 2 main conclusions are, first one, non-time-based queues is better than the other 2 in terms of efficiency of bandwidth utilization. And the other is the benefit of reducing the worst-case latency to a flow of interest could outweigh the extra delay caused by imposing ingress shaping. And for the future work, we will think about better algorithms and also the stochastic network calculus. So, thank you. That's all for my presentation. Any questions?
Dear teacher, good afternoon. The title of my paper is Research on Information Transmission Characteristics of a Two-Layers Communication Network. This paper has 5 part content. First is research background and significance. 2 is exciting method. 3 is the method of this paper. 4 is practical application. 5 is conclusion and prospect. I will focus on the research background and significance of the project, the existing method, the method adopted in this paper, and the application in practice. Research background and significance. With the development of the internet technology and the popularity of a mobile terminal, people's interaction mode has changed from offline to online, from real information exchange to virtual information exchange. Therefore, the use of the social network analysis technology to study the behavior of information dissemination discipline. There are 2 parts of the information communication in social network analysis: disease transmission and information transmission. Novel coronavirus pneumonia has been launched in Europe since the Black Death in mid-13th century. Research has begun to study the mechanism of disease transmission. As the outbreak of the 2019 new pneumonia outbreak has occurred, Many scholars have focused more on the research and analysis of the mechanism of disease transmission. On May 29, the pneumonia cases in China were basically cleared, while the overseas country, especially the United States, were in the outbreak period. The main reason was that China take effective measures to prevent and control the epidemic situation in time. In addition, in view of the problem of information diffusion in social networks, we analyzed an indication about the death of deer Wenliang on the microblog and tracked the spread of the event within 3 days. As shown in the picture, the Internet name strongly expressed his fearing for the event, and the information spread all over many provinces and cities. Based on the above background, there are also 4 problems. First is the diffusion or control of positive or negative energy information in information dissemination. The control of disease in the process of disease transmission. 3 is the industry network planned from design and recommended servers according to the information used by user. And the last is the research and judgment of network public opinion. Around the above problem, it is particularly important to find information on the mechanism of disease transmission and take reasonable control measures. In the analysis of information dissemination mechanism, the following 4 processes are generally used for analysis. First is the establishment of a network model. 2 is the introduction of a communication mechanism. 3 is the analysis of a communication process. And the last is the research on the control stage. The second part is the common method in the study of information dissemination. First of all, in the aspect of the network model, scholars have expanded the classical random, small world, and scale-free network model, and extended the single-layer network model construction algorithm to multi-layer network model. For example, the professional Xia of Tianjin University established an online and offline 2-layer information network propagation model in the analysis of a communication model, and the one-to-one relationship was adapted between layers. Secondly, there are 3 transmission models. The first is SI transmission model, in which S is a susceptible state and I is the transmission state. In this model, with the passage of time, all susceptible states are transformed into I state, which does not conform to the law of disease transmission. Therefore, Research put forward SIS transmission model, in which individual of transmission state become susceptible individual with a certain probability. In order to describe the transmission mechanism more realistically, research have proposed SRI transmission model at the immune state. Individuals in the transmission state become immune state after treatment. Next is the characters analysis of a communication process. Infection rate. According to this picture, we can get a conclusion that with the increase of the infection rate, the earlier arrival time of the outbreak provide. And according to recovery rate, we can from these two pictures, we can get conclusion that first, in SIS transmission model, the higher the recovery rate, the higher the individual distance of a network. Second is in SIS transmission model, the higher the recovery, the slower rate of a return to zero. And the next content is a control stage. There have 3 points. At first is segregation, and second is immunity. Third is immunity stage, and it have random target and quantities. And the third part is the research method used in this paper. Firstly, a two-layer network model is studied and constructed. Secondly, based on SR transmission model, this paper analyzed the information transmission process of a two-layer network. Thirdly, the immune stage in the two-layer network. Finally, is through the actual data construction and analysis of the two-layer communication network APP programmation process and countermeasure. And it is the method construction of two-layer network model. Especially is step 2, and step 2 is growth and professional connection of a scale-free network. In each time step, a new node is introduced and connected to exit old node. Here, at the same time, the probability of a new node connection with an exciting old node satisfy the follow relationship with the degree of the node. When the total network node research and this step is end. And the next is the control street. In this paper, ROADM target and the contents immune stage are used, and the transmission of a progression rate indexed in three kind of two-layer network is analyzed. The first part is the application of general results in practice. During my internship, the company provided mobile phone user app usage data for interns. Therefore, after process the data, I modeled and analyzed the separate of popular social app used by user. The data is the communication behavior and the type of the app used by students in a university from 2016 to 2019. It can be seen that the app was high user utilization rate, mainly include WeChat, Microblog, and QQ. Firstly, a two-layer communication network model is construct and the topic and the model characters of network are analyzed. The degree distribution is power law with small cultural coefficient and larger average path length. Secondly, based on the SRR progression measure, the progression process of app is analyzed through simulation. With the increase of a program rate, the peak value is endeavored transmission rate also increased. Information transmission is directly proportional to the cultural coefficient and inversely proportional to the length of the average path. Therefore, use the progression rate for analyzing in the real network. The progression rate is very small, so the interval testing of communication is also rapidly reduced. Then the propagation process of the three popular app is analyzed. First with the same recovery rate and the transmission rate, the peak propagation of a communicator increasing with the increase of the internal susceptibility scale. 2. When the recovery rate is the same and the transmission rate is different. With the increase the transmission rate, the speed of the radio of three communicator to reach the peak is faster. Finally, the emotion stage of three kind of app application are analyzed. It is concluded that the target immunization and contents immunization stage have good counter effect on the three kind of information. Therefore, if the app is no longer recommended for consumption, it will not be recommended. And the 5th part is the conclusion and the prospect. And the next is the expectation. That's all. Thank you.
Hello to all of you. My name is Hemant Rathore and I will be presenting the paper Detection of Malicious Android Applications, Classical Machine Learning versus Deep Neural Network Integrated with Clustering. First of all, let me thank Broadnets for accepting this paper and allowing me to present this paper on the forum. So this is the outline of this presentation. We will start with introduction. Then we are going to talk about related work in this domain and followed by contribution of this work in the domain. Later on, we are going to talk about experimental setup and performance matrices, which include malware and benign application dataset, generation of feature vector, and evaluation metrics for clustering and classification algorithms. Later, we are going to talk about experimental analysis and results. So in this, we will start with the basic baseline malware detection model, and then we are going to talk about malware detection model based on classification integrated with clustering. And finally, we are going to conclude the paper. So let's start the presentation. So let's start with the basic definition of malware. According to Bears et al., malware is a software program that meets the harmful intent of a malicious attacker. Malware can compromise computers, can steal confidential information, send spam emails, bring down servers, penetrate networks, cripple infrastructures, etc. etc. Malware include viruses, worms, trojans, spyware, bots, rootkits, etc. Now, malware can be present on smartphones, personal computer, etc. So let's talk about smartphones. Smartphones have penetrated very deep into our society. Today, smartphone is used by around 69% of the global population, which is more than the people using electricity, bank account, running water, car, landline, etc. Smartphone also uses operating system for resource management. In 2009, there were multiple operating system players in smartphone marketplace. They were BlackBerry, Symbian, Windows, etc. etc. But if we look today, this market is occupied by only two players. Android having a share of 85% and iOS from Apple having a share of around 14%. So that is why we are building malware detection engines for Android operating system. Now let's talk about related work in this domain. So we will first discuss about different types of malware, static and dynamic, and different types of static malwares, and followed by we are going to talk about different malware detection mechanisms, and then we'll discuss about the proposed approach which we have used to build the malware detection engine. So let's start. So static malwares are those malware where the malicious code inside the malware remain fixed. Now there can be different types of malware, different types of static malware depending on their properties. So a virus is a piece of code that attach itself to the host program and activated by the host program. In case of worm is a standalone malicious program which runs independently. On the other hand, Trojan is a software program that pretends to be useful but perform malicious activity in the background without users' knowledge. Bot, on the other hand, is a malicious application that allows botmaster to remotely control the infected system. Spyware are the type of malicious program that spies on the user activity without users' knowledge. Right. So these are the different types of static malware, and these are having specific properties, and that is why we are calling them as either virus, spyware, etc., etc. We can merge multiple of these properties to make another malware, and that we are going to call it as hybrid malware. So hybrid malware combines two or more other forms of malicious code in a new type to achieve more powerful attack functionality. So these are static malware. In case of dynamic malware, the structure of the malware changes dynamically so that they can evade the detection process. Again, if a dynamic malware have a property of viruses, then it is a dynamic virus, right? If it has a property of spamware, then it is a dynamic spamware, etc., etc. Right. So once we know that these are the different types of malware, we are going to talk about detection mechanisms used today to detect these malwares. The first detection mechanism is called signature-based detection. In signature-based detection, first the signature of the malicious code is is generated and stored in the database. Once once the process is done, whenever a test file is test file is received, a signature of that test file will also be generated, and it will be matched. The test signature will be matched in the entire database of virus signatures or malware signatures. If the signature of the test file matches to the database, then we know that the particular test file is malicious in nature. So that is how a signature-based detection mechanism will work. So signatures here are often manually generated, decimated, and maintained by domain experts. So this is one of the bottleneck of signature-based detection mechanism, because it is completely human-driven, right? Human has to be in the loop to generate signatures and to deploy those signatures at the customer end. Typically, the timeline to generate signatures is around 54 days, and 15% of the samples are not even signature of 15% of the samples are not even generated after 180 days. So this is a pretty reactive approach, where first the malware is written, it is deployed over the internet, and the antivirus company has to get a sample of it, then a signature can be generated, and then it can be stored or deployed on the database to be checked for the test file, right? So sort of a reactive approach. This is a sort of a reactive approach, and it doesn't save us from zero-day attacks. So antivirus community has come up with something called heuristic-based malware detection, where domain experts will try to write rules and patterns which can differentiate malware and benign files, right? So they will try to write rules and patterns that can separate malicious and benign files. These rules should be generic enough to detect malwares, but should not raise false alarm for benign files, right? But writing these rules are pretty hard, and these type of heuristic based approach will typically give high false positive rate. So writing these rules are pretty hard, while containing the false positive rate is a hard task. But again, it's a proactive approach. We do not need a malicious sample. It's a proactive approach, but it needs a lot of domain knowledge to write those rules and to control the false positive, right? Now, this is how a typical antivirus will look like today, where it has two parts. One is on the client side, which is on our laptop or PC, and one on the server side, which is on the antivirus side. Typically, the crawler will run on internet and will try to sample or get malicious samples. Once a sample is identified to be a malicious, then signature of that malicious sample is generated and is stored in the virus database. This virus database is synced on the client side whenever we are updating the definitions, and then whenever we are running the antivirus, the test file, the signature of the test file will be generated, and it will be matched with existing signature in the database. If the signature matches, then the test file is malicious. Otherwise, it is benign in nature. So this is how a typical antivirus or traditional malware detection system will look like. But the problem here is it is highly human driven, and it has higher false positive. So researchers and antivirus community has tried to identify or use machine learning and deep learning for malware detection process, right? So here in this paper, we have used this pipeline to build the malware detection models. So we will start with data collection, and in data collection, we will collect malicious and benign samples. Once the data set is generated or collected, then we are going to perform feature extraction. Features are backbone of any classification algorithm, and we have used opcodes, Android opcodes, to build the detection engine. Once the feature extraction is performed, then we are going to generate the feature vector which contain the Android opcodes, which are 256 in number. Then we can perform various feature engineering or feature reduction tasks as per the needs. And after that, we can use machine learning and deep learning algorithms to build the classification model. Once the classification model is built, then domain knowledge can be used to understand the classification results. So this is the pipeline we have also used to build our detection engine. So what are the contribution of our paper, right? So we are able to build Android malware detection models using opcode as a feature, with random forest as a classifier, and it achieved a highest AUC of 99.4. We also found out that instead of directly building classification model on the dataset, segregation of vector space using clustering followed by classification further improve our AUC to 99.6 using the same classification algorithm, random forest, right? In one cluster, and direct detection of malware on another cluster, right? So this is another contribution. The third contribution, which we found out, that instead of building one complex malware detection model on the complete data set, which might underfit and overfit the data, we can segregate the vector space by using clustering algorithms, and then build classification algorithm, or then use classification algorithm to build classification model on each of the clusters to reduce the curse of dimensionality. We also compare deep learning versus machine learning approaches and found that deep learning method typically take a lot of computational resources as compared to machine learning approaches. So let's talk in detail about this paper. So we'll start with evaluation metrics. For clustering approach, we have used sum of square error, Shilioid score, and Kalaski-Herbite score to actually check the understand the quality of the cluster. So to understand the sum of square error, this is typically the distance of a particular point in a cluster. This is the distance between x, which is a particular point, to its nearest center of the cluster, right? And we do it for all the clusters, and we do it for all the points. So this is how we calculate the sum of square error. Shilioid score is typically relationship between cohesion and separation of different clusters. Kalaski-Herbite score is basically sort of, we are trying to find the sum of square error of a within cluster and outside cluster. So this is how we do it in Kalaski-Herbite score, right? So for classification algorithms, we have used accuracy, true positive rate, true negative rate, and F1 score. For to calculate the accuracy is true positive plus true negative divided by true positive plus false positive plus true negative plus false negative, and so on, right? We can easily see this is the standard thing, right? So again, we also perform PCA to understand the data statistics inside the feature vector, and we found out that typically malicious samples will be together in the vector space as compared to the benign samples, right? So here we have projected two principal components, principal component 1 on the x-axis, principal component 2 on the y-axis, and we have projected all the data points. Here also we can see that the red samples, which are malicious in nature, are very close to each other and are very are in a close group, right? While benign samples are pretty scattered. So we can say that malicious samples belonging to the same family will be close to each other in the vector space as compared to the benign samples, which are very scattered throughout the vector space. So this is the result of different baseline models we have created, and to build the final malware detection model, we have used 8 different classification algorithms like decision tree, K nearest neighbor, support vector machine, random forest, ADA boost, DNN with 2 layer, DNN with 4 layer, DNN with 7 layer, right? So here the highest accuracy was achieved by random forest, which is 95.7, right? And highest AUC is also achieved by random forest, which is 99.4. So this is the best result we have achieved on the original data, and the random forest performed optimally here, right? And F1 score is also highest for RF only. If we are comparing in terms of test and train time, the deep learning algorithms are taking higher amount of train and test time as compared to the machine learning algorithms. So right, this is one of the contributions we have done in this work. Now, so as we have discussed the idea already, what we are trying to claim here is, instead of using one complex machine learning model for the complete data set, we are first going to divide our data set into multiple sub-vectors using clustering algorithms, and then we are going to build classification algorithm, detection model using classification algorithm on each of the cluster, right? So here first we have to identify different clusters. So we have used five different clustering algorithms to identify the best type of clusters on the given data set. So we have used K-means, agglomerative, merge, GMM, and DB scan here, right? So, initially we started with different number of clusters for the complete data set. So K-means was ran for 2 clusters, 3 clusters, and 4 clusters, and Chilliard and Kalaski-Harbaugh score was noted down. Same thing was done for agglomerative, merge, GMM, and DB scan. And here we can easily find out that K means with 2 clusters. K means with 2 cluster gives us highest Chilliard score and highest Kalaski score. So that means that if we are using K-means clustering algorithm on this given data set and dividing into 2 clusters, we are getting highest Chilliard and Kalaski score. That means we are getting almost perfect clusters. We have also used elbow method and dendrogram to understand the number of clusters in the data set. So here, as we can see that in elbow method, which is figure 4, we have plotted the sum of square error on the y-axis and number of clusters on the x-axis. When the number of clusters is 1, the sum of square error is very high, but when the number of clusters are 2, then the sum of square error is drastically reduced and it stabilizes around 3 or 4. So as we can see from here that a bend is visible at 2 or 3, so number of clusters in the data set is number of optimal clusters in the data set is either 2 or 3. And supported by the argument of Chilliard and Kalaski score, we can say that the number of clusters are 2 here. We also made dendrogram to understand the number of clusters for agglomerative clustering, and here we can see that we can cut the threshold at either 2 or 3 again to get the optimal number of clusters. So finally, we use K-means clustering algorithm with number of clusters as 2 to divide the vector space, right? So empirically we found out this, and that is why we use K-means clustering algorithm with 2 clusters to divide the vector space. So now we have 2 clusters, and then on each of the clustering algorithm we built classification model, right? So we used again the same 8 classification algorithm. We used again the same 8 classification algorithm on cluster 1, and what we found out were improved results. So the accuracy was again improved, and of course AUC was also improved. Again, since we have reduced the curse of dimensionality, we were able to reduce a bit of train and test time as well. The good part was in cluster 2, 98% samples were benign, right? 98% samples were benign in nature. So very rarely there was a malicious sample, and even if there was malicious sample, they belonged to only one family, right? So that is why segregation of vector space gave us clearly separated benign samples and few samples which contain malicious and cluster 1 which contained malicious and benign sample. There also we were able to improve the performance. So to finally conclude, what we have achieved in this work is traditional malware detection systems are failing to cope up with volume, velocity, and sophistication of malware attacks performed on smartphones. So we want to build a new age detection system. So we first built baseline detection model using random forest, and which achieve a ROC of 99.4 with a higher accuracy, higher TNR, and F1 score. Right. Later we perform clustering to first segregate the vector space and then build classification model on each of the cluster. And we found that there is an improvement in AOC score and improvement in the accuracy as well. And further, we were able to detect malicious sample. We were able to find that the cluster 2 only contained benign sample and very rarely malicious sample belonging to 1 or 2 families, right? So the experimental result shows that instead of building one complex malware detection system which might underfit or overfit the data and can suffer from curse of dimensionality, we can use segregation of vector space using clustering followed by building classification model to have improved malware detection model. Thank you all for listening. Take care. Bye-bye.
Hello, this is Ricardo Martinez from CTC. This work is entitled at the experimental evaluation of routing spectral assignment algorithm for software-defined networking programmable VCSEL-based, elicible bandwidth variable transceiver in high-capacity and cost-efficient optical metro networks. This work has been produced within the context of the European Passion Project, and the partners involved are CTC, Telefónica, and Universidad Carlos III, all of them from Spain. This is the outline of this talk. First of all, I will motivate the work. Next, I will overview the Passion Project solutions and contributions. Next, I will concentrate on the underlying routing and spectral assignment algorithm, which is the focus of this work. These algorithms are experimentally evaluated within the CTC adrenaline testbed. And finally, I will summarize this talk. Optical method networks are being enhanced in order to become more flexible, efficient, agile, and supporting higher capacity. This means that these networks should be cost efficient and provide reduced power consumption and footprint. Moreover, they need to be programmable and configurable. Such challenges are being addressed by the European Commission Passion project, exploiting two main concepts and technologies. The first one is the photonic technology and dense photonic integration, and the second one is the network programmability provided by a centralized SDN controller. Here, this slide provides an overview of the Passion contributions and solutions. The first one is to design a software-defined networking control S-BVT, selection bandwidth receiver, which allows generating multiple flows by enabling and disabling the pool of lasers, the VCSELs, that operate at a fixed wavelength, as well as to configure the coherent receiver at the destination. The solution covers the complete C-band in order to achieve terabit per second capacity in integrated design. Here, this picture represents the S-BVT transmitter. The main element is the module, which is the element integrated in a single photonic chip. This module is made up of 4 submodules. Each of these submodules has 10 VCSELs, 10 lasers. Each of these VCSELs provide a capacity of 50 gigabits per second. So a module is able to reach up to 2 terabits per second. Depending on the metro network necessities, 4 of these submodules can be integrated in order to provide a supermodule which is able to allow up to 8 terabits per second. The second contribution of the Passion project is the automatic configuration of the whole underlying network elements constituting the transport infrastructure. In other words, the S-BVTs, transmitter and receiver, and the optical switches. This can be achieved via a defined RESTful APIs. The description and details of these APIs can be found on this work. The idea at the end is to provide the dynamic computation of the network resources, spatial and spectral, in order to accommodate incoming optical connection requests. In order to do that, it is needed to trigger a routing and spectral assignment algorithm that allows selecting the resources to accommodate the incoming connection requests. Therefore, the goal of the routing and spectral assignment algorithm is then to dynamically accommodate the optical connection requests, which specify the source, the destination, and the required bandwidth, while attaining an efficient use of all the overall network resources in terms of the VCSELs, coherent receivers, and the optical spectrum. The inputs for the routing and spectral assignment algorithm are the network topology, specifying the link distance, the node connectivity. In this work, we have considered that the VCSELs may provide different operational modes depending on the number of hops and the path distance being traversed by the connection. In other words, even if the VCSEL is able to provide 50 gigabits per second, depending on the number of hops and the path distance, the net data rate received at the destination may be lower than this 50 gigabits per second. In the high mode, for instance, the data rate at the receiver is 50, the highest one, as long as the path distance is not larger than 30 kilometers and the number of hops does not exceed 5 hops. On the other hand, in the low operational mode, the data rate at the destination is 25 gigabits per second, but the maximum path distance is 150 kilometers and the number of hops is 15. All the optical flows to be accommodated in this network should fulfill the spectrum continuity and continuity constraint for the entire path. This means that the same optical resources should be allocated on all the links being traversed by the connection. The output of a successfully computed connection by the algorithm specify the VCSELs at the source node, the coherent receiver at the destination node, and the nodes and the links, as well as the allocated frequency load for all the optical flows satisfying the connection request demands. In a specific VCSEL operation mode, high, medium, or low, a request may need a number larger than 1 optical flows in order to be set up. For instance, if we have a request of 100 gigabits per second and the operational mode that we can use is 40 gigabits per second, we need 4 optical flows to be set up in order to fulfill this bandwidth. This means that we have to allocate 4 VCSELs at the source node, 4 coherent receiver at the destination node, and 4 frequencies load over all the nodes and links to be traversed by the connection. Bearing this in mind, we have devised 2 different routing and spectral assignment algorithms. The first one is the RSA routed optical flows, and the second one, which is the contribution of the work, is the RSA inverse multiplexing optical flows. Which are the main features of these 2 algorithms? For the co-routed algorithm, all the optical flows for a given request need to be set up over the same spatial node, spatial path, the same nodes and link, but allocating different frequencies load, VCSELs, and coherent receivers. In order to do that, first we compute the shortest path between the source and the destination, which are sorted by the path distance and the number of hops. And starting from the highest operation mode, which provides the higher data rate, we explore all the path in order to find the most efficient solution. For each of these paths, we have to verify, we have to check that the path does not exceed the operation mode restriction, in terms of the maximum path distance and number of hops, that all the optical flows can be, in order to fulfill the bandwidth of the connection request, can be accommodated, and each of the optical flows satisfy the spectrum continuity and contiguity constraint, and there are sufficient available resources in terms of VCSEL and coherent receiver at both source and destination endpoints. For the inverse multiplexing algorithm, the idea is to enhance the network resource utilization with respect to the co-routed algorithm. In this case, we relax the necessity of establishing all the optical flows over the same spatial path, and the different optical flows for a given connection request can be routed over diverse spatial paths. This means traversing different nodes and links. It operates similar as the co-routed algorithm. First, we compute the shortest path for the source destination. Starting from the highest operation mode, we make a subset of the shortest path in order to, as long as the operational mode restrictions are fulfilled. For this subset, the idea is to accommodate all the optical flows over the different paths forming this shortest path subset. Again, all the optical flows need to be set up satisfying the requirements, the constraints in terms of the spectrum continuity and continuity. This is an example in order to illustrate the difference between the co-routed and inverse multiplexing algorithm. Let's assume that we receive a request of 100 gigabits per second between the source and the destination. In order to fulfill the request, we have to set up 2 different optical flows, X and Y, operating at 50 gigabits per second. This means that we are relying on the high operational mode. In the co-routed algorithm, both optical flows, X and Y, are established over the same spatial path, traversing the same nodes and links, but allocating or occupying different frequency slots, as we can observe here. In the inverse multiplexing, the optical flow X is established through this path, through this spatial path, but the optical Y can be established over a different spatial path. But again, we are restricted to allocate different frequency load for both optical flows, because this is due to the fact that the VCSELs operate at different wavelengths. Next, I will describe the experimental performance evaluation in order to compare both algorithms. We have considered this method network shown here. It is formed by 20 nodes, 20 servers, which emulate the slice of bandwidth transceiver of the optical switch agents. All the connections need to be established between the access and the core nodes. This means the access are this element here, the black boxes and the black circles, while the core node is this blue box. So all the connections should be established between this pair of nodes. All the connections are generated according to a Poisson process with an inter-arrival time set to 5 seconds. The connection duration is exponentially modeled with an average holding time expressed in 5 seconds. As we have commented before, all the connections are unidirectional, where the bandwidth is uniformly distributed between 50, 100, 150, and 200 gigabits per second. The performance metrics are the block bandwidth ratio, which is the block bandwidth with respect to the overall requested bandwidth, the average number of used VCSELs and coherent receivers, and the average setup time. The average setup time considers the time of computing the resources done by the routing and spectral assignment algorithm, and the time required in order to allocate the resources on the different elements forming the connection. We have considered different K values for the shortest path, 1, 3, 6, and 9, and the holding time has been varied in order to provide different traffic loads. Well, here we represent the results of the block bandwidth ratio with respect to holding time for the co-rooted algorithm and the inverse multiplexing algorithm, considering different K values. We observe that as the holding time is increased, the block bandwidth ratio is worsened for both algorithms. This is expected since more connections coexist, occupying resources, which complicates the algorithm to find a feasible solution. Moreover, it's worth to see that increasing the K value, we can improve the block bandwidth ratio because more candidate paths can be explored, which allows or which favors to better deal with the spectrum constraints. In this picture, we compare both algorithms for the K value of 1 and 9. We observe that we don't achieve significant differences between the both algorithms. Indeed, both algorithms perform very similar. So the expected improvement provided by the inverse multiplexing with respect to the co-rooted is not really reflected. The main reason of this behavior is that the considered standard ring topology does not really favor the root diversity needed by the inverse multiplexing in order to achieve a better performance with respect to the co-rooted algorithm. Then we will describe other performance metrics that we have gathered. The first one is about the average number of used VCSEL and coherent receiver at the source and the destination. We observe that increasing the K value of the shortest path aims to occupy more resources at the source and the destination. So for this reason, as we increase the K value, we can achieve a larger amount of used VCSELs and coherent receivers. On the other hand, with respect to the setup time, we observe that increasing the K value in both algorithms leads to explore more candidate paths. So this means that we need to increase the computational time achieved by the routing and spectral assignment algorithms. But it's important also to see that in the case of the inverse multiplexing optical flow, these algorithms tend to increase the setup time, the overall setup time, because for each connection request, more paths are explored when compared to the co-rooted algorithm. Just to conclude, in summary, in order to cope with the high transport capacity in the metro network, we have to provide cost-efficient and lower power infrastructure. And one solution in order to deal with these requirements is to use photonic technologies. In the Passion project, we have defined a modular, flexible, and programmable metro network architecture. In this work, we have focused on comparing two different routing and spectral assignment algorithms, the co-routed and inverse multiplexing RSA algorithm. It was expected that the inverse multiplexing algorithm does improve the performance with respect to the co-routed, leveraging the capability of routing request optical flow over different spatial paths. But from the obtained result, this benefit is not really reflected, mostly due to the topology that we have considered for the experimental evaluation, which significantly constrains the route diversity which is required by the inverse multiplexing. The next steps is to evaluate both algorithms in a more meshed metro network and supporting other appealing capabilities such as online restoration if an optical flow fails. So thank you very much for your kind attention. If you have any question, please don't hesitate to contact me.
Hello, my name is Martín Miga Martínez, and today I'll be presenting the paper Implementing a Blockchain-based Security System Applied to IoT. This paper it's been produced in the CRACS lab in the UPC. This is the index. I'll talk about the introduction of the paper, some motivations which helped me working in this paper, the main objectives, the proposed architecture, where the data will be stored, the final blockchain proposal, some attacks that may harm the architecture, the final implementation, and lastly, some conclusions. In this slide, we see a city, a very bright city, and a world. I'd like you to see here that everything is interconnected between themselves. This could be an analogy to the Internet of Things, where every device can reach the other devices in a meaningful way. It's like they can reach the other devices, send data, such as sensor data, or actions that could be performed in real time, almost real time, so we can help a smart city in its main functioning. But we don't lose track of other important scenarios, such as smart industry. In this case, it's 4.0. The new or the main reason for the 4.0 version is that big data is present. This big data is representing the analytics and statistics of machinery, so that, let's say, for example, some machine is having troubles or may have troubles in the future. If we take this data, process it, and have take the characteristics or some specific information, we could prevent other machinery from malfunctioning or stop working. And by doing that, we allow to not have so much accidents in work, because the machinery is always correctly operating, and having nearly no downtime, meaning no money loss, due to this always on machine. My main motivations for this paper, even though this is an intersection in a smart city, we could also envision this in a smart industry, just changing the intersection for a factory. The communications coming from this factory have and must be secure between themselves, between the factory and the cloud, or any node in the supply chain. The hacker here must not be able to either eavesdrop the communications and know what is going on, meaning maybe, I don't know, the traffic lights, their status, and what is worse, changing the lights, just tampering with them and provoking accidents. So this must be the main priority of this paper, to avoid this from happening. In this example, intersection, if let's say that the purple and the green car are trying to get into the intersection, just by looking at the traffic lights, they could crash into the red car, and there could be injuries or even death. Therefore, even though this is a really maybe edge case, this must not happen in any way. The project objectives are based on designing and implementing architecture able to send, receive, and persist information in real time safely in a smart scenario. Correctly apply blockchain technology when identifying architecture's devices. We must know everything, every detail of devices within the system. By maintaining ACLs of the before mentioned devices, we can achieve that. And perform tests to evaluate real and simulated operation of the proposed architecture. In the paper, we've talked about cloud architecture, fog to cloud, but we needed some more security assurances to provide into this project. So we based on the fog to cloud architecture, where there are 3 layers: cloud, fog, and edge. Fog is the layer which is between these two. It is closer to the end user, which is situated at the edge. Therefore, it can separate responsibilities. Like, for instance, if we have to carry out a really powerful computation, no node in the edge and fog could do that, so they have to forward it to the cloud. But if we have to just have a quick reaction, which we'll see in the next slides, we have to act as closer to the end user as possible. So this is the fog edge, the fog layer, sorry. These are the edge nodes. The chosen of these elements is arbitrary. I found it appropriate for these like edge nodes being traffic lights, road, etc. And the fog nodes being a bus stop, sewer, and public facility, for example. The reachability between themselves can be difficult because of the way networks work. The routing might not be available between themselves due to private networks, network address translators, which obviously if you forward ports you could achieve that, but it's not scalable in any way. Thus we need some technology, in this case virtual private networks, to forward this traffic between this VPN center, which is situated in as a fog node, and all the communications will be encrypted and authenticated using a PKI infrastructure. Because we are using a VPN center and it's processing the requests, it can also act like a firewall in some way, because it can filter using ports, protocols, and even if something is unencrypted, which it shouldn't be, payloads. Now, every element can access to any other element, so they are able to add the blockchain, which this will be also in the fog layer. In this paper, it's using 2 nodes of blockchain, but it could be more of them, just for the sake of simplicity. It will allow us to have the identification and attributes of every device, either fog, edge, cloud. I didn't choose to have the details of cloud for arbitrary motives. But every other device is identified and has its roles specified into the blockchain. Later on, we'll talk about validators, which are nodes on the fog, and gateways, which are nodes at the edge. Validators have the main responsibility of, as the name implies, validating the requests coming from edge nodes. How can a validator do that? Just because it has access to the blockchain. When a request comes from an edge device, this request must be signed with the device's private key, and also give an identifier of which node it is. The validator will gather the public key and just check if the signature is correct. And if it is, just redirect data to the cloud, like for historical reasons. And also, if it has to perform a quick action, like a real-time action which we'll see in the next slides, redirect that request to other edge devices. This is a scheme of an edge device. In this case, it's a single-board computer, the Raspberry Pi 3. It is connected to multiple microcontrollers using the Bluetooth Low Energy, because it uses characteristics and services and it's really useful to this architecture. And the sensors are connected throughout serial peripheral interface, but they also could be interconnected with using serial or WART. The smart city, here it is an example. The sensor traffic lights are edge devices. The bus stop is a fog device. And there's the industry and the cluster, which is this. This acts like a cloud. The example here is a car going through the street. It is over speeding. Therefore, the radar takes a picture of the car. But it doesn't end here. The radar asks for for other validators here, and it finds the bus stop. Then it creates a request using the payload. This car is over speeding with this license. So I sign it using my private key. I send it to one fog node, which is in this case it's a bus stop. The bus stop validates the request using the blockchain, and if it is correct, it performs an action. In this case, telling the traffic lights to, hey, just switch to red because this car is overspeeding. And because we also want to have knowledge of this action, it is also redirected to the cloud. The data storage, which will be both immediate accessibility for the purpose of switching the traffic lights in the previous case, and having the persistency of accessing the data at any time and from anywhere, therefore having the ubiquitous characteristic. The blockchain, here we have 3 transactions, which are gateways and validators. Actually, we can see how we can either modify, add, or delete elements by adding transactions. And we can ban these elements by changing the attribute from ban, and also adding a timestamp just for having the information purposes. The scheme would be search for validators, create the request, sign it, as we've seen in the previous slide. We validate the signature. If it is correct, it sends that to the cloud. Otherwise, it notifies the VPN center. So now we see the normal operation of the architecture. At the bottom, you can see the dashboard, which is connected to a gateway and a microcontroller with its appropriate sensor. Here there are three graphics: the pressure, temperature, and humidity. Buttons to toggle the selection of virtual, real, and all gateways, and a table representing submit info and data. Having seen the dashboard, there are 2 proposal attacks. The first one is the blockchain ban. The left shell implies the blockchain management. Here there is a node which is malfunctioning. Therefore, for this reason, we decide to ban it. We run this code, which is in JavaScript, and after 2 seconds, the device is banned. It has the timestamp the time from now, and we no longer receive any requests. And also, there is system warnings being generated every 6-7 seconds. Let's say that for any reason, now the node is okay. Thus, we can just unban it and adding another transaction. The element is no longer banned, so now we can receive another repeatedly requests from this gateway. Okay, now having seen that we can ban devices, we can also beware of public key signing. So that the same node as before, it is not signing properly, therefore we're not receiving any requests. Notice that this is 7 minutes. We are receiving public key verification failed from the validators because it's not signing properly. We can resist these attacks, and the architecture is working as intended. For conclusions, here we have 2 scenarios envisaged, industry and smart city. Even though I focus these slides on smart city, many of these architecture can be applied to the industry. We have tested the architecture with real and simulated devices, and the blockchain can help us securely identifying devices, as we've seen in these attacks, by just having attributes and being accessed throughout the fog nodes. Thank you all for your attention. This is a picture of me trying if the sensor is in fact working correctly, like for fun purposes. And I hope you like the presentation. Thank you very much. Just have a grateful day.
Hello, my name is Ramon Duran. I am assistant professor at the University of Valladolid in Spain. I am a member of the Optical Communication Group of that university. I'm going to present you today our work, Joint Core and Spectrum Allocation in Dynamic Optical Network with reconfigurable optical add-drop multiplexers with no line chains. The explosion of paradigms like Internet of Things, tactile Internet, or Industry 4.0 are causing the evolution of communication infrastructures. The new applications and services, as well as the number of connected devices, impose stringent requirements that current communication network cannot satisfy. Things, for example, in tactile Internet. In that paradigms, the delay is crucial, okay? And current network cannot provide that delay, communication with that delay. So we have to find solution for that. The first solution is 5G, the use of 5G technology. 5G is a promising technology that supports high number of connected devices and enables high capacity and low latency communications. On the other hand, we also have to put computing and storage resources closer to the end user. So we are going to observe computing and storage capacity from data centers very far from the final user to the edge of the network. And for that, we are going to use the technology multi-asset edge computing. When designing future metro networks, we have to take into account these MEC resources. Thanks to these MEC resources, we are going to take the cloud capability closer to the final user. So we are going to reduce the latency. However, we have to take that resources into account and we have to interconnect them. For that, we have to build efficient metro network. The best solution for that is the use of elastic optical network, because this kind of network provides high bandwidth, high dynamicity, have scalability, and also reliability. Elastic optical networks are the evolution of classical wavelength routed optical networks. In these networks, the wavelength division multiplexing is not only used in order to increase the capacity of the different channels, but also for routing purposes. Elastic optical networks are based on the establishment of optical circuits. We call these optical circuits light paths. In contrast to wavelength routed optical network, in the elastic ones, they use techniques like OFDM or Nyquist WDM in order to allocate a variable proportion of the spectrum to each light path. In that way, we are going to reduce the wasted capacity of using I2T fixed channel, like happens with classical wavelength routed optical networks. However, before the establishment of a light path, we have to solve one problem, that it is the routing and spectrum allocation problem. Routing and spectrum allocation problem can be solved by a central entity called, for example, path computation element, PCE. Then, in the evolution, in dynamic elastic optical network, light paths are established and released on demand. They are requested by end users. In that way, we are going to improve the network flexibility. The objective when designing this kind of network is to reduce the light path blocking ratio. That is the ratio of a light path request that cannot be established in the network due to the lack of resources. Here, as connection or as request arrive on real time, it is very important to take into account the computing time, as we have to solve the routing and spectrum assignment problem on real time. In order to increase the capacity of elastic optical network, recent papers propose the use of multi-core fibers instead of single-core fibers. The drawback of this solution is the increment in the crosstalk between the signal traveling in the different cores. However, in our proposal, in metro networks, we are going to have short distance. Moreover, the demanded bandwidth is not going to be as high as it is in backbone network. Therefore, we can use multi-core fibers with low number of cores per fiber. So, the crosstalk will have a very limited impact in our network, in metro network. When elastic optical networks are equipped with multi-core fiber, the routing and spectrum assignment problems change to routing, core, and spectrum assignment problem. So we add one dimension more to the problem, as we have also to select the core in each fiber of the LiPad. The objective of this paper is to propose two methods to solve the routing, core, and spectrum assignment problem in the elastic optical network equipped with multi-core fiber, assuming a metro network using reconfigurable optical adder multiplexer without line chain. The dynamic routing, core, and spectrum assignment problem definition is that users are going to demand the establishment and the release of LiPad on real time. Each request contains the source and destination node and the demanded bandwidth of the LiPad requested. Then, the algorithm that we are going to use to solve this problem has to provide a solution that must contain the route of the LiPad, that is, the sequence of nodes and fiber from the source to the destination node, and also the core that will be used in each one of the fibers, and also the portion of the spectrum reserved for the LiPad. When we are solving the routing, core, and spectrum assignment problem, we can consider different constraints. The first one is the spectrum continuity constraint. This constraint happens because there are no wavelength converters in the network. Therefore, the LiPad must use the same spectrum in the complete route. This constraint is usually considered in most of the papers that implement or that propose a routing and core spectrum assignment method. The second one, the core continuity constraint, appears because in the paper of Rumipamba, it's shown that using an architecture of a reconfigurable optical adder multiplexer without line chains is much more economical at the expense of a little reduction in the performance. Therefore, they are very suitable for metro network. However, we have to ensure that the LiPad must use the same core, so the same index, in all of the fiber. So we have a second constraint, a core continuity constraint. In the previous proposal for solving the problem, only Rumipamba used core continuity constraint. The method described in that paper used first fit for spectrum assignment. However, some of the paper about routing and spectrum assignment demonstrate that instead of using first fit, it's much more efficient assigning the spectrum slot that better fits to the LiPad capacity, or the LiPad requested capacity. They call that method best fit. Our method uses best fit, but using the reconfigurable optical adder multiplexer architecture proposed by Rumipamba. So we propose two algorithms. The first one uses first fit core assignment. It uses pre-calculated key shortest path for solving the routing problem, first fit for core assignment, and best fit for spectrum assignment. Well, this is a pseudocode of the method. The complete pseudocode is in the paper. But the idea is that we solve each problem independently. Once the routing, also the core assignment, and independently the spectrum assignment. In the second method, we also use, but that is called best fit, we also use pre-calculated key shortest path for solving the routing problem, but we solve jointly the spectrum assignment and the core assignment. And in both cases, we use the idea of best fit. So we are going to search between all of the possibilities in each core, which one has the best fitting to the demanded bandwidth requested by the user. So both the core and the spectrum assignment are solved jointly. In order to test our proposals, we have simulated in OMNET the topology NSFNet. We know that topology is a topology of backbone network, but we have adapted the distance to the range of metro network. Then we consider only 2 cores per fiber in order to reduce the effect of crosstalk. And the variable capacity per core is 4 THz, so more or less the bandwidth of C-band. We use 2 slot sizes, one of 12.5 GHz, like most of elastic optical network proposals do, and also 50 GHz, like classical slot, that is the classical slot size in wavelength routed optical network. LiPath request will arrive at a Poisson process. Source, destination, and request bandwidth from 1 to 30 GHz are generated using an uniform distribution. Here we have the results that we have obtained in our simulation. Firstly, the blocking ratio, depending on the different proposal and also on the load. Okay. In blue, we have the solution that we obtained using a slot size of 50 GHz, and in red, 12.5 GHz. And then in empty symbol, we have the best core assignment, so the method that solves jointly the core assignment and the spectrum assignment. So the first conclusion that we have is that we obtain is that we are going to obtain better performance when we use smaller slot size. Obviously, this is something that always happens in elastic optical network, as we use the spectrum in a more efficient way. The second one, that is the most interesting one, is that solving jointly the core and also the spectrum assignment, like the best core assignment method does, we are going to obtain better results. Then, if we analyze the other important parameters, the computing time, depending on the load and also for the same methods and with the same colors. Firstly, I want to say that we have not used any parallelization in order to, for the sake of comparison, even when all of the methods can be easily parallelized. So what we see is that the computing time is smaller with higher slot size. With higher slot size, we are going to have lower number of slots, and it is easier to find a solution. That's why it is faster than using a slot size of 12.5 GHz. However, comparing our two methods, we can observe that we obtain similar computing time in both algorithms for low loads. So in that load in which the blocking probability or the blocking ratio that we saw in the previous slide is lower or is below 10 to minus 3. In conclusion, we have used cost-effective architecture for the metro segment of 5G network when they are equipped with MEC resources. There we have proposed two algorithms in order to solve the routing, core and spectrum assignment problem. And we have considered that our metro network is equipped with multi-core fibers and also with reconfigurable optical outdoor multiplexers without line chain. Therefore, we have imposed constraint in both the spectrum and also the core continuity constraint. One version explores sequentially the spectrum of each core to find a solution. The other method jointly allocates the core and spectrum to each light path. We performed a simulation, and what we obtained in our simulation is that when we solve both problems jointly, so the core and spectrum assignment jointly, we are going to have a reduction in the blocking ratio, so the network is going to be more efficient at the expense of a very little increment in the computing time. We want to thank the Spanish Ministry of Science and Innovation by two projects, the Go2Edge network and also Onofre 2 project. We also want to thank the European Commission for the Interreg Pocket Tech project Disruptive. In case you have any question, any doubt, please write me an email. Thank you very much for your attention.
Hello, I'm José Alberto Maestro, and the rest of the authors of this contribution are Sara Rodríguez, Roberto Casado, Javier Prieto, and Juan Manuel Corchado. We work with the Visitor Research Group at the University of Salamanca, and the title of the contribution is Comparison of Efficient Planning and Optimization Methods of Last Mile Delivery Resources. The contribution is split up into two main topics: a literature review of recent last mile delivery approaches, and also our own proposal based on collaboration. Last mile delivery is increasing its importance due to the growing population living in cities, and also because of the deliveries associated to e-commerce. It has some advantages, such as maintaining the supply of goods in cities, support the economy, or increase the customer satisfaction, but also has some drawbacks. For instance, decrease the congestion, air pollution, greenhouse gas emissions, traffic accidents, noise, and so on. It's responsible up to 20% of vehicle traffic in cities, so its optimization can contribute to increase the sustainability of the service and also to a significant reduction of the side effects. Reducing the economic cost of last mile delivery has been attempted several times, usually by reducing the length of the roads using optimization algorithms. A general description of the problem could be: several carriers compete with each other in the city, and this results in a fragmented market, a lack of coordination, and thus a low vehicle load factor, so much vehicle movement, a high cost for the overall system, and some environmental side effects. If we focus on proposals using collaboration, we can classify them in three main groups. First, single route optimization using any kind of collaboration. Second, increasing the vehicle load factor. And three, joint optimization of multiple carriers. The different approaches found in recent literature can be arranged from no collaboration to full integration, as it's shown in the picture. Single route cost reduction has been approached using, for instance, crowdsourcing. In this approach, a set of individuals deliver parcels along their routes using empty space, for example, in their cars or luggage. This is a win-win approach, as it's obtained a better customer experience and individual gets some additional income. This has been approached in several ways. For example, transfer parcels between occasional drivers to avoid long detours, or using trucks to deliver the parcel to the city center and at arranged locations perform a cross-sourced delivery to final recipients. It has been also proposed the use of alternative means of transport, such as public transport when possible, for example, using bus, trams, tube, taxi, or others. And also the use of mixed public transport and e-bike for reducing the environmental side effects. Increasing the vehicle load factor is other of the approaches chosen for collaboratively reduce the cost of last mile delivery. The objectives are reducing the distance the parcels travel by using an intermediate hub, and avoiding additional trips when parcel cannot be delivered to the recipient because maybe the customer is not at home. Its main drawback is that it needs additional infrastructure. In order to increase the vehicle load factor, the use of multi-echelon network has been proposed. This is because sometimes having just a depot can be inefficient due to long trips. Other factors, such as time windows, for example, can also lead to reducing the vehicle load factor. The use of satellite hubs to consolidate and deconsolidate deliveries can increase the vehicle load factor, and also not delivered parcels can be left in the satellites. Other approach to increase the vehicle load factor is the urban consolidation centers. It's a way to balancing the interests of carrier receivers, citizens, and public administrations so that the hub is located within the city limits and it is easily accessible. And also the consolidation center increase the vehicle load factor and reduce the distance traveled, because it's used for several carriers to deliver the consolidation in the consolidation center. However, it has an economic impact in the last mile delivery, and also the success of the consolidation center can depend on some constraints that are out of the control of the carrier, such as, for example, establishing a low emission zones in the city. Using both approaches at the same time is possible, and it has been proposed to use when designing a new distribution network for a city. Other proposal is performing a joint optimization of several carriers. This is a collaboration approach, although not always with the same goal. For instance, it has been proposed that carriers delivering on a route ask the stores on the route to anticipate their orders. And another approach is using multi-agent systems where each agent represents a carrier and collaboratively the agents optimize on the routes. Another proposal is to share resources of the carriers. For example, it has been proposed that several carriers coordinate and collaborate to increase vehicle load factor so that the parcels are delivered from the most appropriate depot. Another proposal is that several carriers join in an alliance. All the reviewed proposals have been classified according to the kind of solution they propose. Whether the delivery solution is thought for customer or for business, for example, storage, and also according to the approach they use to the solution. For instance, agent-based solution, machine learning, heuristic, or an exact solution. This table summarizes the classification. All the approaches have some benefits and some drawbacks. For instance, single road cost reduction approaches try to reduce the cost by reducing the stops on a road, but neither allow for global optimization nor increase the vehicle load factor. Also, the cross-sourcing approach is scalable, but delivery quality can decrease. The literature includes some drawbacks for the consolidation center approach that can make them fail, and that can be summarized as lack of a proper planning for the consolidation center, too ambitious forecast, dependence for subsidies, and too high operation cost, or wrong decisions such as wrong depot place or wrong vehicle choice. The integration of carriers also has some drawbacks. The proposals analysis basically consist of uniting the carriers into one, as it's seek to reduce the cost of the delivery, but other constraints that are not taken into account. For example, the size of the depot or the number of bytes for the tracks. We think that there is room enough to make our own collaborative proposal. The idea of consolidating deliveries to increase the vehicle load factor that is present in the consolidation center is interesting, but the drawbacks, mainly the operational cost of the new delivery infrastructure, can make the idea infeasible for all cities. We think that a cost reduction can be achieved by collaboration without establishing a new infrastructure and also avoiding the integration of several carriers just into one. Our alternative is focused on a collaboration approach that consists of basically to perform a general optimization of the routes and share some parcels between routes after they are proposed. Our proposal is divided into 3 steps. Each carrier builds their own routes for delivery. The routes are sent to a common share optimizer. The optimizer will try to improve the routes in a win-win basis. If it is possible, some stop for parcel delivery on one route will be changed to another route if the delivery can be done at a lower cost. To obtain a robust, flexible, configurable, and extendable solution, an agent-based approach is proposed. A multi-agent system consists of several agents that will seek their own goals or the global goal. Behavior such as goal delegation or collaboration can be present in a multi-agent system. We include the use of virtual organization of agents that allow for managed collaboration between agents and multi-agent systems. Virtual organization allows that agents and multi-agent systems coordinate resources and services across their organizational boundaries. We propose an agent-based solution that provides some advantages when dealing with a complex problem. For instance, it can be distributed in computers and organizations. It is able to deal with complex communications and can have independence in the behavior of the agents. Some proposals reviewed already include agent-based solutions. The solution obtained can have versatility and capacity to be distributed and be scalable. In our proposal, each carrier is represented using a virtual organization, which is capable of performing several processes, such as optimizing the routes, and that having into account some external information, such as weather forecast, traffic information, possible works on the road, and others. The possibility of using machine learning in each agent for learning from their own data is also taken into account. The common SAR optimizer is also present as its own virtual organization. It also needs external information to optimize the routes after introduce the changes to share some parcels if this is possible. Using virtual organization will allow the system to add or remove carriers easily and thus to adapt to change in the environment. For small cities, a single optimizer can be enough. Although for big cities, this solution can be replicated for smaller areas such as neighborhoods. Cloud deployment provides flexibility, availability, and capability to change the scope and the computing requirements. An exact global solution is not considered due to the computational cost. Instead of that, a heuristic solution is proposed to select those stops that can be changed to another route, so that the candidates will be those stops that are close to a stop in another route. If a stop on a route is moved to another route, a transfer point for the parcel should be also added. The transfer is not necessarily a synchronous event, as possible locations for transfer parcel include the carrier's depot, parcel lockers, stores, or others. Once the stop and routes are exchanged, a new optimization process can be necessary for each route, as many alternatives can be possible and artificial intelligence hybrid approach is proposed. First, an expert system is in charge of selecting the best algorithm depending on the delivery features. For example, the number of stops on the road or the presence of constraints. Then the most suitable algorithm is run to produce the new optimized route. The possible options are heuristics, machine learning, or even an exact solution if this is possible. To ensure a win-win approach, two constraints are considered. The carrier who loses the stop does not worsen its cost function, and the new routes reduce the overall cost. This way, both local and global optimization is taken into account. As final remarks, it must be said that a review of a recent proposal for last mile delivery has been presented. A classification has been proposed based on collaboration. Some advantages and drawbacks of the proposal solution has been identified. A new proposal for route optimization based on collaboration has been included. It seeks to reduce inefficiencies in the delivery process due to the distance to some stops. It also seeks for local optimization for each carrier and at the same time for global optimization. And the solution is divided into two steps. first stops on a route that can be best served on another route are identified, and if it is feasible, move to the other route, and as any route can lose and gain stops, a new optimization process is developed using artificial intelligence hybrid approach. Thank you very much for your attention.
Hello, I will present the word decision-making under uncertainty for the deployment of future network in IoT scenarios. My name is Néstor Alzate and I am PhD student at Polytechnic University of Catalonia. The other two authors are Professor Germán Santos Boada from the Polytechnic University of Catalonia and José Roberto de Almeida Amazonas from the University of São Paulo. To get in the subject, let's analyze the evolution of the different approaches to digital environment, as shown in the figure 1. In the first moment, the approach system-centric is based on the operating system supported by the hardware where it is installed. As evolution, the approach application-centered focuses on the application and considers it as the starting point, while taking in account the preference and change of the different actors. In a third moment, the approach network-centric implies that the infrastructure of the network is at the heart of the architecture, the air condition or request for service. Finally, the approach human-centric proposes the optimization of both service and network application by centering the decision on the well-being of the individual. To accomplish this, network performance is assessed by the considered both traditional quantitative and qualitative data. Qualitative data generated by individuals either directly through opinions posted on web page or social media, or through interaction between individuals and their device, which log human activities on several platforms on each one emerging technology concepts, as presented on the outside of the figure 2. Human activities determine network issues behavior through resource requests. However, the uncertainty produced by individuals through their perceived experiences influence data communication network performance to a greater extent. As for uncertainty, this can be produced either by human or by device. On the human side, uncertainty can be produced by several factors like irrational behavior, linguistic inaccuracy, subjective judgment, ambiguous opinion, or vagueness in desire. On the device side, factors such as inaccuracy in data sensing, noise data, and incompleteness data introduce uncertainty in decision making. Decision making involves selecting of the best option from a specific set to solve a given problem in the best possible manner. These research studies center on computational decision-making systems, especially those that accept design with a significant degree of the process automation and are able to handle uncertainty. A classification of the most significant methods described in the literature is listed in figure 4. We have grouped the techniques or methods in multiple criteria decision-making, optimization method, and machine learning. Here we will focus on multiple criteria decision-making for which tools have been extensively studied. Different multiple criteria decision-making methods may be classified depending on the academic current from the European, American, and another school. The European school uses the following methods: elimination and choice expressing reality, electric. This is used to eliminate non-viable solution alternatives. This method is usually combined with another multiple criteria decision-making method to minimize execution times. Preferred ranking organization method for enrichment of evaluation, Prometheus. This method is founded on mathematical and psychological methods used to develop an external classification for various alternatives, to helping agents to choose the option that best serves its purpose as based on understanding of the users. This method has been assessed in several fields, such as electric power and engineering decision-making, among the others. In the North American school proposes the following methods: analytic hierarchy process, AHP. This method is structured to manage complex decisions based on appraisal and assessment, combining physical and psychological elements which are usually in conflict. From different origins we can name multi-criteria optimization and compromise solution, BICOR. Is a method for determining the best possible solution, especially when dealing with conflict options or with different units of measurement. In fact, there are several proposals for this method. For example, one is to combine this method with other techniques to develop a method for assessing feelings in social media, for group decision-making process, or for evaluating airline service quality. Technique of ordering preference by similarity to ideal solution, TOPSIS. This method seeks to find an alternative solution with the shortest and longest Euclidean distances for the optimal positive solution and the optimal negative solution, respectively. These solutions are mostly addressed in the study with this method with supplement by additional algorithm. Data Available Analysis, DAI, is a methodology created to assess the relative efficiency of comparable entity sets by solving a series of the mathematical programming model. The scenario of mobile wireless sensor network is an example of uncertainty with the IoT network, as shown in Figure 6. The mobile wireless sensor network resources are limited, especially in terms of precise capacity and power independence. In this scenario, multiple mobile wireless sensor network standalone drones intercommunicate without requiring the infrastructure of a physical network to monitor and identify intruders in specific neighborhood areas. Figure 6a provides a late-night example, at hours when it is unlikely the persons will be out in the street. Nevertheless, a sensor finds an intruder, and based on the condition at the moment, the only possible route is resolved sending an alert to the control station. However, because the sensors are moving, various situations may be happening that may render to choose route unfeasible, such as one or more sensors being outside coverage range or hardware failure. Figure 6b displays how one of the drones is left offline because the multiple signals detected exceed the maximum processing capacity. This is driven by an event that forces sector residents to live in mass, such as catastrophic, astronomical, or other events occurs. This shows the value of the making context-based decision because uncertainty is likely to disappear. A smart space is a physical environment in which people and technology enable systems interact in an increasingly open, connected, coordinated, and intelligent ecosystem. Figure 7 denotes a scenario of a home focuses on the care and well-being of an ill person who requires monitoring on her activities and vital signs, because her health may be affected by changes in light, temperature, humidity, and noise. These variables will also have to be controlled. This particular scenario depicts a house furnished with all types of sensors and portable devices used for controlling the environment and alerting nearby hospitals if needed. The idea is to provide immediate assistance by sending an ambulance. In addition, her social media are also monitored to supplement the data and in some cases to provide additional context to the data extracted from the sensor. Nevertheless, situations may occur in which uncertainty does not allow for clear decision or wherein they may lead to incorrect decision. For example, if the person decides to take a nap on the floor, it may appear the patient is fainting or suffered an accident, depending on when the images of video taken are seen. If a person is watching a horror movie, their pulse may be disturbed, but if a video is not able to determine what activity the person is doing, the data from the portable device may be causing a false alarm. This example will show the context awareness is a significant matter when managing uncertainty in decision making. To examine the impact of the uncertainty on Industry 4.0, let us review the scenario of a call center providing customer service for a mobile phone company. The main goal of this service company is to provide timely attention as many customers as feasible. Therefore, the average time of the user call is a significant factor that must be controlled because network resources are limited, whether in terms of telephone line or bandwidth. To streamline this resource, among the other technology measures adopted, the call center has a customer relationship management system to provide user and record, monitor and track and predict events. System data are registered after received user consent, whether from social media, information from cell phone, or through other means. The information recorded in the customer relationship management system support processing requests received by various means such as telephone call, social media, chats, or email in a more efficient manner. Nevertheless, if this information is not properly contextualized, the opposite effect can be created, thus actually increase the time spent in the response at request and using more network infrastructure resources. The following example presents a case where people uncertain affect resource used for the proposed scenario. Let's assume that some user has been selected to answer a loyalty survey with an estimated maximum time frame. Based on the criteria, users select if they had stated they were daily satisfied with the service. In addition, user has to be young, assuming that handled a new technology better, belong to high socioeconomic status, reside in an urban population, and have complete minimum academic levels. Nevertheless, when the call center agent places the corresponding calls, some respond who meet all criteria except the condition or situation that significantly increase the time required to complete the survey. For example, a few may have some cognitive disorder or answer the call while perform some other activities that they continue doing currently as they provide their response, such as playing video games, or some maybe have some mild hearing, vision, or speech impairments. At this point, we describe the main open research problem arising within this context, classified as present in the figure. Concern on network connectivity. Mobility is one of the main characteristics of the modern networks. However, depending on the technology, mobility might face challenges such as radio spectrum reservation and allocation, bandwidth allocation, transfer, and routing. If communications are between heterogeneous networks, this situation may become quite complicated. Therefore, standardized self-organization mechanisms are required for the infrastructure to adjust the constant changes caused by mobility and user demand, regardless of technology. Concern on security and privacy. Security risks can be economic, environment, and organization consequences that may be related to personal, social, or industrial environments. Even people life may face some time of risks. Malware impact device connected to network might reduce data and communication network performance and compromise packet delivery to such an extent that the whole network might collapse, among the other examples. Elements related to decision making. It is somewhat challenging to make decisions on cross-cutting issues, such as human-centered network management, due to the different types of resource used, such as a heterogeneous network, several types of sensors and devices, and the vast number of the data collection source, among the others. Based on this reason, reaching agreement on the standard is a continuous improvement issue. Further, integration decision-making and machine learning is an exciting matter due to the large amount of data, processing capacity, and the range of techniques that must be adjusted to needs under uncertainty. Challenge related to sensors and devices. Regarding electronic devices, they take samples and report the behavior of the environment variables or for the individual of where these variables were created. In both instances, Problems arise in terms of the access condition to power, grid, or communication network, and especially for wireless sensor, which in general exhibit decreased processing resource, battery autonomy, or wireless range. These constraints contrast with the demand for resource needed when applied machine learning techniques, which imply that identify computational efficient strategy in essential component. Various device manufacturers are another issue, since each has its own input and output data form, protocols, and interface and highly interoperability and smooth operations. As conclusion, we can say that human-centric networks are destined to transform how we live our daily life. Nevertheless, the intensive use that may be given to human-centric network may generate high traffic rates that will have an impact on that communication network resource. In this study, we present a comprehensive review of several decision-making computational methods like multi-criteria decision-making, optimization algorithm, and machine learning proposed for dimensioning, control, and deployment of the future network. These methods have been separately and jointly assessed in different fields. However, several decision-making methods combinations are clearly yet to be explored, especially those related to machine learning methods. In addition, we believe that new multidisciplinary computational paradigms must be developed to address several uncertain factors. Although it is below the scope of this review, information security is a relevant issue to the implication and the scope that may be feasible when processing private personal information. Therefore, we think that strong emphasis should be placed on methods aimed at limiting potential abuse with personal data, as otherwise, the emerging concept of human-centered network will lose all credibility. Finally, based on review of the emerging concepts such as smart-based and Industry 4.0, the lack of standardization is clearly evidenced, even when the heterogeneity of the definition. Thank you.
Hi everyone, my name is Nacho. In this presentation, I will show you the work me and my colleagues at the UPM have done. This work has been called an initial approach to a multi-access edge computing reference architecture implementation using Kubernetes. Hope you enjoy. We will first introduce the edge computing paradigm, the reference architecture that ETSI defines for MEC, and how cloud-native applications can be useful for MEC. Then our whole MEC proposal is described. To conclude this presentation, we will give you a demo that shows the prototype we have built to validate the whole MEC proposal. So, what does multi-access edge computing mean? We must first understand what edge computing stands for. Edge computing is a new network paradigm that moves cloud resources closer to the end users. As a result, this paradigm provides multiple benefits such as low latency, efficient bandwidth usage, fine-grained location tracking, or task offloading. ETSI first standardized the term Mobile Edge Computing, MEC. This term was later renamed to Multi-Access Edge Computing to cope with different access technologies at the edge. ETSI created an industry specification group which is currently working on providing specifications for the architecture and the involved APIs. ETSI MEC defines a two-level reference architecture as shown in the picture. At the MEC system level, the most important element is the MEC orchestrator. The MEC orchestrator is the core of the system, performing tasks such as managing the MEC application packages or requesting the instantiation termination of MEC applications across the available MEC hosts. At the MEC host level, we find the MEC platform manager. This component is responsible for the lifecycle management of the MEC applications that run on a target MEC host. The MEC host is considered an entity that contains a virtualization infrastructure that supports the instantiation of MEC applications. Within the MEC host, there's the MEC platform that configures and registers MEC applications to consume and/or provide MEC services. Due to the benefits that MEC provides, MEC is considered a business-driven technology. It opens a new ecosystem for innovative applications that need to adapt quickly to market demands. For this reason, ETSI encourages the implementation of MEC by following DevOps practices. One of the current trends is the development of cloud-native applications. There is no official definition for cloud-native, though there is a generalized understanding of it as a set of modern cloud techniques which aim at building scalable, dynamic applications that can quickly adapt to changing demands. By splitting applications into independent services, the development of applications is facilitated as each microservice can evolve at a different pace. Containers enable portability, code isolation, and fast instantiation, what makes them the perfect choice for running microservices. However, building and deploying containerized applications introduces complexity that requires some kind of orchestration. Kubernetes, also known as KHS, is an open source orchestration system of containerized applications. Kubernetes adoption has rapidly grown in the past few years, making it the de facto orchestrator for microservices. Kubernetes can also play the role of the MEC platform manager, as it provides scaling, scheduling, or fault tolerance features that address the lifecycle management of containerized MEC applications. On the other hand, we've got Helm. Helm is a popular package manager for Kubernetes. Helm bundles the Kubernetes resources that comprise an application into a Helm chart. In this work, we propose mapping the Helm chart to the Make application package concept. We can find several open source platforms that implement the Make paradigm. The most popular is Acraino. Acraino is a Linux Foundation project that provides an open source Mac system where OpenStack and Kubernetes are used as VIMs. However, this project is not aligned with the ETSI standard. Another open source project is Airship. Airship was originally created to deploy OpenStack components by means of Helm, although now it can also be used to deploy Mac applications. ETSI recently proposed merging the Mac and NFV standards so that Mac applications could be deployed as VNFs. The open source Mano platform might be an option for this Mac in NFV architecture. However, working groups are still investigating this matter, as it is not yet clear how the mapping between NFV and Mac should be done. Now let's move on to our proposal, the Helm Mac middleware. Kubernetes alone presents a limitation in order to work as a Mac platform manager, which is Kubernetes is not aware of the Mac application concept. We propose a setup where Kubernetes leverages Helm to manage Mac applications as Helm charts. The open source project FluxHelm Operator is an implementation of a Kubernetes operator to manage the lifecycle of Helm charts. Helm Operator defines the Helm chart as a new custom resource definition, ACRD. Therefore, making Helm charts as first-class objects in Kubernetes. As a result, the Helm operator can be considered a generic Mac platform manager for Mac applications. By introducing the Helm operator, Mac applications can be defined in a declarative way through Kubernetes. This feature provides the means for integrating Kubernetes and Helm with the ETSI reference architecture. In this picture, we illustrate the different REST APIs among OSs, Mac Orchestrator, and Mac Platform Manager that ETSI has defined in the reference architecture. Between the OSs and the Mac Orchestrator, there is the MM1 reference point, which contains APIs for package management and application lifecycle management. Between the Mac Orchestrator and the Mac Platform Manager, we find the same APIs plus a third one meant for notifications. In this work, we propose an implementation of a new layer within the Mac Platform Manager to support the different APIs of the MM3 reference point. This layer has been named HelmMac. This picture shows the pieces that comprise the Mac Platform Manager, the KTS control plane, and the three main components of HelmMac: HelmMac proxy, FluxHelm operator, and a NoSQL database. The HelmMac proxy is a web server that handles REST requests through the MM3 reference point and translates them into interactions with the Kubernetes control plane. The HelmMac proxy uses a NoSQL database to store all the information related to Mac application instances. This information is required to run operations to create, delete, instantiate, and terminate application instances. Helm charts are onboarded on the Mac Orchestrator as Mac application packages. This information is used by the HelmMac proxy upon instantiating an application in order to let the Helm operator know where to fetch the Helm chart. Once the Helm operator processes the Helm chart, it eventually orders Kubernetes to create the resources that compose the Mac application. To validate the HelmMac proposal, we have built a prototype based on the virtual scenario as shown in the right-hand picture. The virtual scenario is deployed using VNX tool and the machines are configured with Ansible. The prototype is split into two levels. The MEC system level contains the MEC orchestrator, which is deployed as an LXC container, which runs a web server program with fast API framework. This server implements the MM1 package management API. The orchestrator runs MongoDB to store the MEC application package information. In this level, we also find the user's host, which allows users to interact with the system, playing the role of the OSS. At the MEC host level, two KVM machines run a Kubernetes cluster deployed with kubespray. The MEC proxy runs on Kubernetes as a containerized web server, also programmed with fast API. This web server implements the MM3 Application Lifecycle Management API. Additionally, a containerized instance of MongoDB runs on Kubernetes. This instance is responsible for storing MEC application instance information. We would like to thank the Spanish Ministry of Science, Innovation and Universities for supporting this work. In this demo, we will show you how you can deploy and interact with the prototype that we have built for this proof of concept. We will walk you through some of the main steps such as onboarding a MEC application package, launching a MEC application, and terminating a MEC application. The code of this prototype is publicly available on GitHub. We invite you to visit the repository and play with it. We will start this demo from a newly created scenario. Remember, we must first deploy the scenario using VNX tool, and then we configure all the machines using Ansible playbooks. Now let's access the Kubernetes master machine. If we list the pods in the default namespace, we can see there's the MEC proxy running along with its Mongo database. If we do the same thing under the Flux namespace, we see the Helm operator is running. Thanks to the Helm operator, we can now manage Helm charts as first-class objects in Kubernetes. If we list these Helm charts, we see no applications have been deployed yet, except for MongoDB. MongoDB, in this case, is used by Helmec, and we have leveraged the Helm operator functionality to ease the process of deploying it. Now let's get to the first step. In this step, we will onboard a new MEC application package. We will send a request from the user's host to the MEC orchestrator. All the REST APIs have been built using the FastAPI framework. This is a great Python framework for prototyping REST APIs. FastAPI auto-generates an OpenAPI specification for all built APIs, and additionally it provides a friendly user interface to play with. In the case of the MEC orchestrator, we have these operations available to manage MEC application packages. If we list them, we can check there's nothing stored yet. Now, let's onboard a new MEC application package that contains a Helm chart that will deploy a Grafana. These are the parameters we must specify to onboard a new package. We will call the package Grafana, set the version to 566, provider Grafana as well, the application path from where to fetch the Helm chart, and optionally a dictionary of user-defined data. This is very interesting as Etsy already covers the possibility to override default values of a package. Let's onboard the package. And here we can see that an ID has been generated and is set to both the package ID and the descriptor of the application. The package is onboarded but not used. Let's get to step 2. We will now create a MEC application instance from the package we just onboarded. For a strict alignment with Etsy specification, this request should be sent to the orchestrator, that in turn would forward the request to the platform manager. For the sake of simplicity, we will do this directly to the platform manager. Now we will get the external IP of the HelpMec proxy so we can interact with its REST API. And here we have the same user interface as before, but in this case with operations to manage application instances. If we list them, we see there's nothing yet. No applications deployed yet. So now let's create a new application instance. In the request, we specify the application descriptor of the package that we just onboarded. We also set a name and a description for the Make application instance. Now, an application ID is auto-generated, and if we list the instances again, we see there's this new one, which is not instantiated. If we go back to Kubernetes and check the applications, there's nothing yet, because the application has not been instantiated. Step 3. Now we will instantiate this application instance that we just created. Here we take the application instance ID and select the instantiate operation. Operation was successful, and if we list the application instances again, now the status has changed to instantiated. If we check this on Kubernetes, we now see that there's a Grafana helm chart that it's been installed. Grafana is now installed. So let's get its external IP so we can access this new service. We introduce the username and the password that we specified while onboarding the package. And here's Grafana. Step 4. Now we will terminate this application instance. Similar to the previous step, we will check the application instance ID, and this time we will select the terminate operation. Operation successful, and if we check the application instance, we will now see that the state changed to not instantiated. If we check this on Kubernetes, we now see that the application is gone. And the final step, step 5, we will delete this Make application instance from the database. Once again, we check the application instance ID, but this time we will send a delete request for this application instance ID. Operation is successful, and if we check the instances in the database, it is gone. So that will be it. Thanks for watching.
We are happy to announce the Best Paper Award for Analysis of QoS Schemes and Shaping Strategies for Large-Scale IP Networks Based on Network Calculus. Chen Li Hao, Zhongjia Yi, Gol Tao, Wang Xinyan. Huawei Technologies. And we also welcome all of you to pay attention to Broadnets 2021.